You gotta be kidding me. You gotta be kidding me. Yeah, no, got it. Got it. No, I don't know what. Sorry, guys. Okay, so whatever. Start over. Yeah, we'll start over. System here. I can't be bothered. Okay, no. So the thingy I was showing. So wait, how much? I have to go over everything, don't I? That was just random anecdotal stuff, so I don't know. Is that worth it? Either way, the 960, I was using it for testing some capacitors as well as the power mod. So I sort of showed you that. No sound on that. Sorry. Swear, it's just... seriously, it's just... I hate having to run my own live streams. It's like, I can barely organize my own life enough to not die, and it's just... Remember to turn on the sound. No, so I used the 960 for testing the power mod. So that was that sort of mess of a circuit by the 6-pin on there. That was the power mod on it. The system we're running here is the usual, you know, DDR4 from Team Group, running 3200 CL14. So you know what? I'll just put you on the monitor. We can go over the system spec. So, yeah, it's a Ryzen 7, 4 gigahertz, 1.4 volts. The voltage reading in CPU-Z is completely broken. The motherboard is limited to a maximum of 1.4 volts, which is really, really, really concerning since, well, I want to run this for the ROG OC Showdown, and 1.4 volts is not enough for overclocking Ryzen for benchmarks at all. And for liquid nitrogen, it's just not enough. And the problem is this motherboard uses an ASP 1106 voltage controller from Asus, which is some rebranded part. I have no idea what it is, so I can't volt mod it. And my contact for Asus is really busy with Computex, so he's not answering any of my questions. So that's great. So. Yeah, but it does run 4 gigahertz. I might add some extra capacitors to it. I am considering just e-powering the motherboard, but if I have no datasheet for the voltage controller, there's a good chance that I replace the VRM and it doesn't turn on any longer, and I won't know how to make it work. So yeah, there's the memory settings. I have run this system all the way to. The best memory settings I've gotten on this was 3200, 12, 11, 12, 28. But yeah, there's currently no AGSA 1006 BIOS for this board. It's still on 1004, so I can't go past 3200. So yeah, let's just get this card up and running. It is the 1070 here. Does have a liquid metal shunt mod on it. So the power limit is reduced a little bit, but it's not enough. This card is really, really bad in terms of like the shunt mod. It's not working anywhere near as much as I'd like it to. I think this thing does like 140. We'll just get a baseline score, and it does do 500 memory. So it does have Micron memory ICs, but it clocks okay for the fact that they're Microns. Max out all the sliders. So we'll just get a baseline score here from TimeSpy, and I'll open up GPU-Z so that we get some power monitoring. I can't keep my eye on both the chat and just keep track of the freaking audio at the same time. Sorry. It's not too much stuff for me, because basically my entire day, I wake up and I'm like, I want to try the mod, I want to try the mod, I want to try the mod. It's pretty much the only thought I've had in my head this entire day. And so focusing on anything other than doing the mod is just not working. So let's run Time Spy. I did apply everything, yeah? Yeah, I did. What? The 3200 on this motherboard? That's not the motherboard, that's the memory kit. This memory kit, I'm 99% sure I could stick it into any Ryzen motherboard and it would run great. It would run 3200 because it is a Samsung B-die kit. It's rated for 33 megahertz. And it's, what the hell? Oops, an error occurred. Don't oops, an error occurred me. But, yeah, this memory kit just run, like, I've only had 2 Ryzen motherboards, but I don't think there's a motherboard out there that this wouldn't do 3200 on. Does the music pick up that much? Because I was doing like tests before the live stream about how loud the music is, and it just doesn't seem that loud to me. But I don't know. Everybody always keeps complaining on the YouTube videos that I'm too quiet, and then when I sound check them for myself, they're fine. It's just, I don't know. I should give up. Let's just give up on that. If people, okay, so do people want the music louder or quieter? Because last video everybody's like quieter, and before that I never had any complaints, so I just went to the old way where it's just, it picks up randomly off of my speakers. Because I can't stand being in silence, I get paranoid. Music is fine. Do not, do not raise it. Just leave it, please. Okay, I see a lot of people do not appreciate my taste in music. As long as I can't hear the fans of the card, I'm happy. So... No, actually, me and the artist, the reason why I have this music specifically playing every live stream is because me and the artist have an agreement. Plus, it's all, like, freely accessible, so... You won't, like, I won't have issues playing this music. I know there's another live stream where I had Fear Factory playing in the background, and that got flagged for copyright. And you could barely hear it. It still got flagged. I have no idea what YouTube's problem is. And... there we go. Let's get our score. This is not going to be... I think it's going to be higher than... Yeah, okay, so it's higher than the score I've already posted, but it's still nothing amazing. You know what's so annoying? I know on the Tai Chi I can get easily over 9,000 at 4 gigahertz, because I can, like, I get over 9,000 points for physics on a better motherboard, so I'm just like, I'm really not pleased here, but... Yeah. What? The thing about, so the ROG OC Showdown competition requires Asus motherboards. I am not buying an Asus X99 motherboard. They cost way too much. So I'm stuck using Ryzen for the competition, so it doesn't make sense to test on the 6950X. I couldn't. Like, yeah. And plus, I don't really care about global points on NVIDIA cards anyway. It's just like, no. This is literally just to get, like, just for stage 5 of the ROG OC Showdown. I couldn't, like, as soon as that's over, assuming this card doesn't die, it's going. It's going far away. I never want to see it again. But yeah, so here we have a score of 6,696. That's not too bad. And we can clearly see that we have some power throttling. Card's doing about 2 gigahertz for the most part through both tests. So that's nice. Voltage is fluctuating all over the place because of the power throttling. In the initial test, there's actually basically no power throttling at all. So, yeah, that's sort of the baseline. Let's break the power circuit. Let's break that power monitoring circuit, because that's the best way to fix NVIDIA's power limit. Because you can't, like, apparently the NVIDIA BIOS is untouchable. I quite frankly don't care about NVIDIA BIOS, because it's an NVIDIA card, you know. The 960 by some miracle ended up in my possession. The 1070 is gonna be leaving as soon as possible. The less I have to deal with NVIDIA cards, the happier I'll be. And hard mods, in my opinion, solve things much faster and much more reliably than BIOS mods. So, let's get to the hard modding. And this is not going to be fun. Put you on the... Oh, wait. This one. Yeah. Yeah. And I'm going to need a data sheet. Where's my phone? So actually, I'm going to have to mark up the card before we start. Otherwise, I'm not going to know where I'm soldering. So give me a second while I scribble all over it. And where did my red Sharpie go? There we go. I do already have the data sheet open, so it's not going to take me a month. It's just a case of finding the pin out. God, I hate this data sheet. Like, this one's really, really bad. I mean, it has lots and lots of details, but it's like trying to figure out how the chip is mounted on the PCB and how it's wired is just... It couldn't be harder. Literally could not be harder. Because they just refuse to mark where the dot, like there's never an indicator of where the dot on the chip is. So that is how convenient. So that's positive. That's also positive. And that means, okay. So, here we go. So we have the card, and I've just put a bit of red Sharpie on the... So the thing about the current monitoring chip is basically what we have here is this chip right here. That's the... Oh, great, glare. That chip right there is an INA 3221 from Texas Instruments. That's a 3-channel voltage and current monitoring chip. The way it monitors the current and voltage, well, it monitors the voltage, it calculates the current, and then you get power draw. Thing is, we can feed it whatever the hell we want if we know how to rewire it. So we're going to be rewiring it. And the first thing I'm going to do is so I need to knock... This is really risky because it might stop working completely, but the 960 worked, and when I was testing on the 960, I intentionally tested if you short across one of these capacitors, well, if you short all 3 of those capacitors, you lose the power reading. Like the power draw reading that you normally see in GPU-Z, that entire part just disappears. Instead of being like 0% power draw, it's just not there. So I assume the chip shuts down if you do that to it, or something like that, and I assume that's the trigger for safety mode on the 10 series cards. So this should work. This really should work, and if it doesn't, then I am really, really screwed, because I do not have another 1070 to try this on, and I am not good enough to, because basically, we need to knock out these tiny little, there's these tiny little SMD resistors, and those need to go. And yeah, we're going to get rid of them. So, and after those are gone, then we can solder in the actual power mod. So, convenient thing is, since they're so small, I can just take the big tip and run over them, and they're going to be right off. Yeah, it pretty much eats them. So that's one. I'm going to try one channel at a time to hopefully not trigger the card right off the bat. So we're going to try first this channel right here. And so at this point, okay, so that's my 100 ohms. That's my 470K. And I might need something smaller. So I'll just grab a, how many? Well, I have a ton of 18s, so we'll use those because I don't like to, I'm trying to intentionally use up my my resistor supply sort of, well, the same amount of everything, so that when I go restock, I can just buy one of those many resistor kits. And that's that channel done. I'm not sure where I want to pull 12 volts from. I'm thinking I want to pull it off of the PCIe slot, because if by some miracle I decide to e-power the card, the PCIe slot is still going to be functional, whereas I may or may not decide to disable the 6-pin, in which case, disable the 8-pin. And if I do that, then there's not going to be any 12 volts power here, and this hack will stop working. On the other hand, this is a much closer source of 12 volts, but I don't really think that matters. So, just going to pull some solid core wire. And I use the solid core stuff for this kind of thing because it doesn't need to move, and you can get it into shape and then it stays in that shape. So we'll basically have it going from here. And then I need it to bend down to there. I want to route it around all the screw holes, so we're going to have it go like... Is the light too much? I think I... Oh, oops. Knocked something off the desk. There. Okay, so let's see. I want this to go from here. So this is really not that straight, fortunately. Really wish it was. It would look neater. Not that I should really care that much, considering this is going to look like a disaster anyway, but I can at least try, damn it. So we'll have to bend it like there. Yeah. And then to there. There we go. Wire fell down. There, like that. And it does reach both ends just fine. So I'll just make sure that I can, well, maybe it would be a good idea to check that the capacitor pad I'm going to be soldering onto is actually 12 volts, which it should be. And it is, that's 0. So that is 12, perfect. That's what I was hoping for. So, where's this go? There we go. I also tried capacitor modding this card, and that was really unsuccessful. It did not make it clock any better, so It looks like Asus did a really good job with the 6-phase VRM on here. Which kind of makes sense, because in my testing so far, it's like 4-phase VRMs, piling on some extra capacitors tends to help a bit. Or a lot, if they're really like the GTX 570, for example. That 4-phase VRM is just straight up trash. So when I put some capacitors on that, it picked up a ton of extra core clock. The 960 picked up like 5 megahertz from adding capacitors, but this thing just does not care. So this VRM seems to be pretty damn good as is. But maybe once I give it more Vcore and core clock, it'll actually start caring more. But yeah, because testing at stock for capacitor mods generally shows really miserable. Like, it often doesn't show any gains because your power draw isn't high enough. There we go. Just make it, oops. To keep you flat. There we go. Actually, that's a nice place. Well, no, I don't want to be pulling ground from all the way over there. That's dumb. Try grab ground somewhere near the actual thing, but yeah. Let's do that side. Actually, I should prepare that capacitor first. So let's see if I can just get it right off the bat, which I doubt, but we shall. Yeah, no. Oh, there we go. That's not bad. Okay, yeah, that actually wetted right off the bat. That's convenient. And that side too. There's some small SMDs near it that I really don't want to hit, but there we go. That's an awkward angle to have this held at. Let's get this side hooked up. I probably didn't have to remove both of, well, yeah, I probably didn't have to remove both of the resistors, but whatever. There we go. It's too bad I don't have like a good fixture down here for the thing. It's standing up, but oh well. I don't like how that looks. It doesn't look like... Looks like the capacitor is fine, but it's just the wire that's not hooking up properly. Yeah, that's not going to go anywhere. Try bend this down so that it stays better. Something like that. Damn it. Oh well. So we do have 12 volts going there. And eventually what I'll do is I'll just pull from that one 12 volt point to all the other ones. So we'll just set up one divider. It's not like I'm going to set up multiple dividers for every single one of these little monitoring circuits, but yeah, so we hit our 4,700. This will go straight to ground, so I just need to find a ground point for this thing. Well, looky here, we have a capacitor mount. There's one side of that should be to ground. Unfortunately, if you're measuring, well, this side should be ground. Let's see. How convenient. The problem with 10 series NVIDIA cards is that the GPU core itself has an extremely low resistance. So if I measure across like this capacitor right here, it just reads 0 ohms, which is not great. But the only way to get around this is to get a milliohm meter, and those things are expensive as hell. So hopefully, I think that's a capacitor for the memory VRM, so yeah, that's memory. That's 83 ohms. That's 0. Perfect. So, yeah. One other idea I've had is, since I'm going to be disabling the PCIe power limit, is I might rewire the 6-phase VRM on this to the 8-pin entirely. But I haven't yet checked how the 6-phase here is actually wired. Now then, where did my... Yeah, okay, well, we'll just prepare that pad. Come on. Yeah, that works. For some reason, these unoccupied SMD capacitor pads are really, really easy to wet. Except on... Well, no, I haven't actually found a card where I had a problem with these. These are like my favorite thing to try soldering onto. Everything else is hell. And by far the worst are SMD capacitors, like big SMD capacitors. They might as well be made of, yeah, that's a 470. So, might as well be heat sinks. I'm kind of feeling like it'd be nice if I had a second 12-volt source near this. Whatever. Let's get that in. I'm gonna burn myself. I'm so gonna burn myself. I didn't burn myself. That's good. But that is a really messy attachment. I don't like it. Wait, come off. I'll shorten that down first and then reattach it. I was thinking maybe have it full length, but I guess having uninsulated leads all over the car. I mean, technically, the entire thing is uninsulated leads. It's just for some reason I get paranoid when I add more of them. So, I don't know. Doesn't really make sense. It's fine when it's like any of these capacitors is just like has voltage on them that if you pull it to ground, it's going to blow up. And then it's like I add a resistor and I'm worried about it pulling to ground. Pulling something accidentally to ground, but yeah. Think I'll start with the 100 ohm here. And if the power draw turns out, like if the reading turns out to be too high compared to what I actually want, then I'll step it down to something smaller. Then I'll like put another smaller resistor in parallel. I don't want to start off with a really low power reading just in case. Because if it's too high, I can tweak it down. If it's too low, then it's a pain because I'd have to desolder the damn thing. So let's see. I'm gonna get that closer. Go. Let's see how far that will sit. Okay, I need to actually trim that down at this point. Let's see. Yeah, okay, I matched it. Good. Let's attach. Yep. Where's the end of this? There we go. Get that near in case I need more. Oh, yeah. That was nice and easy, except for the part where it's sticking out way too far, in my opinion. I should have just gone for it with the pliers. That does not look at all good for me. There, that looks acceptable by my standards. You know, it might have been a better idea to first put the resistor, then pull the 12-volt line to the resistor. Huh, actually I can still pull the 12-volt line, so just get in there. Up. There. I'll shorten that down and do it that way, because it is smarter. Because I can just, yeah, that's a lot better. Because I can then put the resistor into a more steady position, and here we go. Attach down it. Yeah, there, attached, perfect. Now we can pull 12 volts to the resistor, well, the leg of the resistor, and there. Well, that connection's dodgier than the first one. This wire is like oxidized or something because it just does not want to go on properly. Oh, and there's a bunch of plastic hanging off of it. Where's the box cutter? Go. Ah, that's a bit cleaner. There. That is attached a lot better. It still looks awful, but even by my standards, this is somewhat acceptable. This is acceptable by my standards. So, there. And now we just need to go from this end to that resistor, and we'll have one of these reading garbage. And then if this doesn't fail on me, then we can go and spread that across the other three, and hopefully it'll still work at that point. And this is way too long, in my opinion. I'll have it insulated like that. So there. And need that there to there. There. Oh, this is going to be a nightmare to solder on. Too thin to reliably... I should get some tweezers. I had tweezers. I lost them. Put them on this desk one and never found them again. Need to buy some new ones. Like, clean the desk more. I do. I don't know. I think I might have, like, during one of the cleaning cycles, I might have, like, cleaned the tweezers into the bin, assuming they were garbage or something. Just missed them amongst all the other crap that ends up on this desk. So there we go. Make sure that, yeah, okay, that'll hook up. And let's hook up that end first because that side's more flexible, and that's good. Do this end. That's ugly. That's uglier. That is awful, quite frankly. Way too much. And well, it works. It works, I'll ignore it. So this should function. And from here I can just fan it out to the rest of the capacitors around the... So yeah, that's what it looks like. It looks really... Wait, I'll try enable autofocus, but this is probably... Wait, I'll manual... Oh. What the hell? Oh, no. There. So that's what it looks like. We have this wire, goes across and pulls 12 volts from there, goes to that cap, and then down here, and that's ground. So, yeah, that's how this is wired. I'll put you back on the tripod and then we'll install the card in the system and see if it works. And at this point, it should still work just fine. I'm not, like... As far as I know, you could actually theoretically completely short out some of the shunts, and it should still be fine, but I'm not going to go testing that right here, right now. Now it's really dark again, isn't it? So I'll just... I wish there was, like, a way to monitor the individual channels on the INA3221 from the software, but unfortunately it's like, well, it does have an I2C interface. I guess I could, you know, interface it somehow through the NVIDIA driver, but quite frankly, I don't know how, and I can't be bothered. So, I can't be bothered figuring out how, so we'll just go for this. That's the memory training failing. It doesn't like to cold boot. Like, sometimes I can get 3200 running off the bat, and sometimes it has to loop a few times before it gets you into Windows, but looks like we're good. Yeah, we're posting. So right now I think what'll happen is we'll have really high idle power draw because that is 100 to 470,000, the resistor setup right there. So let's see, wrong mouse. Where's GPU Z? So we should be seeing, yeah, we're seeing 17%. That's really high for idle. We should be power throttling like crazy. But it does look like the mod is working. So that's a good thing. And I'll just configure it down with the 18 ohm resistor after we know that this functions. Afterburner has the, I don't care. It's not connected to the internet. Don't tell me that it's not connected to the internet, garbage. There. Why is the chat not showing up? Oh, this is one of the... Damn. Oh well, you'll see it again once I switch scenes. Wait. Naplip just asked, is it possible to use the VRM of an old GPU plus the one on the card itself, or just a dead VRM or actual VRM of the card? Putting two VRMs in parallel is generally a really bad idea because they might end up fighting each other. Just because they won't necessarily agree on exactly what voltage they should hit, so you'll get... they might burn each other out, especially if one of them is trying to push way more voltage than the other. But if you have a dead VRM, if you just pull out all the chokes, you can do an E-power as normal. Oh, actually, it might not power throttle. I just realized it might not power throttle because the card... Because the PCIe slot power draw is fixed. So even though it's fixed at like, I don't know, 10% of TDP, it's not going to power throttle because we go under full load and it doesn't notice, right? It's still 10%. So this might actually be doing just fine. If you have two... No, even if you have the same VRM twice, you don't want to put them in parallel. You never ever want to have two VRMs in parallel. It's like why you don't... Like, you won't go buy a power supply and combine the two 12-volt rails. No, you won't buy two different power supplies and combine their 12-volt rails, because one of them might put out 5 millivolts more than the other, and we just crashed. And this will be interesting to see the boost, the graphs here. So I think we crashed because we're boosting higher. No, we're actually boosting just about the same, so it's not completely stable. But the mod is working, I think. I mean, we are seeing, yeah, the power draw does look a bit better. We have a lot less power. Yeah, it is working. So let's do the other two and call it a, you know, finish that off, but yeah. Let's just finish this off at this point. Oh, I forgot to turn off the power on by keyboard thing. That is dumb. That is a... Why is it so hot? Oh, right, Right, NVIDIA cards with no power limit get really, really power hungry because you know how everybody's like, oh, NVIDIA cards are so incredibly efficient. It's inherent to the architecture. Well, it might actually be part of the architecture design, but it's not like TSMC has a manufacturing process advantage over global foundries. It's more like NVIDIA cards with the power limit. The way the power management on these cards works is they really won't go over it ever. And I can't remember which one I'm supposed to put you on. That's the wrong one. There. So, yeah, we need to pull a wire from here. Oh, that's going to be so ugly. Okay. Prepare for maximum ugliness. So we do need to pull off some more resistors. And after that, this should be running like an absolute charm, as in no power limit whatsoever. Let's do this. I need to wait for this to heat up a bit because I did turn it off, which, looking back, was probably a waste of time. Almost at 400. Let's see, can I pull this? Come on. Come on. You know you want to leave. I can always use a screwdriver. Useless pile of... Let's see. I'll probably get it off without resorting to more violent methods. Okay, that's that. And... oh, damn, that one's... there's another resistor right next to it. Yeah, I am not going to go for that. I'm going to actually just try knock it out with a razor blade, because there's two resistors right next to each other. One of them is for the current monitoring circuit. The other one, I have no idea, and I really don't want to touch. I should have probably brought a... I should have used a smaller tip for this, but... gently hammer your graphics card. Come on. There. That came right off. Just fine. Perfect. Yeah, okay, so we do have some light PCB damage over there, but it'll work. It'll run. It also looks like that resistor I was worried about pulling off was in series with that other one. So I might have been allowed to pull that one off too, but it's better safe than sorry, I'm going to say on this. So we need to pull 12 volts all the way to here and over there. So we need to... that'd be like the easiest connection, but then it would be a pain to connect to... I also need to connect that, which actually that's easier to do right now. I'm going to do that one. I actually like doing like bridges across these smaller distances because you can basically just strip off a lot more wire at the same time and then just attach at one end, attach the other end, and bam, you're done. Much easier. And you have a lot of like stuff to hold on to instead of trying to... yeah, that's what I want to go for. Yeah. There. So let's tin this copper wire, because otherwise this is not going to work. I need a bigger... I need more desk. That's pretty much always going to be an issue. Okay. Tin, tin, tin. My fingers are on fire. There we go. Because I can just trim this off after it's in place. Oh, oops. That's not where I was aiming at all. Stop moving, damn it. There. So now we're going to cut the wire because it's attached at one end. And then I just need to finish off the attachment on the other. Oh. Well, that's a bit longer than it needs to be, but it'll work. Okay, well, this is going to be a pain. Because it is hovering just above where I needed to hook up. And that hooked up, I think. Yeah, that's hooked up at this point. Cool, cool, cool. So that's the fake 11 point whatever volts hooked up. Now we need to do the 12 volts to the other side, which this one's going to suck more, in my opinion, just because we need to bend it around. We sort of need to go from here, and then... Oh, man, that's a pain. That's, like, such a pain that I'd probably want to pull a separate 12-volt line at this point. Because that needs to go... Oh, man. Yeah, okay. So I'm just gonna... The reason why this is a pain is because I don't have a lot of space to work to not short to the other end, which shouldn't... Well, it might not cause massive... You know, one thing I thought is if you hard lock one of the power limits like this, you might be able to just short the other ones out completely, because you'll have at least one that's reading, but... Did it this way on the 960, I'm just going to keep doing it the same way every time, because I know one way works. I have a working method. I'm not going to try making a potentially better method in the middle of working on a card that costs 350 pounds. How I wish I could just ask for NVIDIA cards, but I'm starting to completely understand why nobody wants to send me NVIDIA GPUs. Because I wouldn't want to send me NVIDIA GPUs. So, there. I'm going to make a little V-shaped thing because this is the easiest way for me to just avoid messing up touching one of the other connections with this little V-shaped piece of wire. That's going to be connecting from one side to 12 volts, which actually this is a bit too long, I think. And this end is not bent enough. There we go. I want that to be as... My fingers are too big. That is rarely an issue. It's usually a case of my fingers get too hot. There. Yeah, that's what I want. That looks pretty damn safe to me as far as connections go. I need to shorten this end a bit more. And bend it. And that is still not bent enough. There we go, that should be good. Yeah, that'll work. Almost. I really... There we go. Now I need to strip the other end as well. Otherwise, because I won't be able to strip this once it's on there. There. Now I attach. This is going to be a massive pain. How does this somehow keep manages to get randomly too long again? Okay, I swear, it was the right length seconds ago. There. That's what I wanted. Now I need that fourth arm to get the freaking thing in place. So, great. My left hand versus stability. Oh, I made it. Perfect. Now we need to get the other end. Now, this is by far the least... Actually, no, this is not the worst, like, hardest soldering I've ever done. But this is the hardest soldering I've ever done that actually led to something that worked at the end of it. Because the other harder soldering I've done was tiny little SMD resistors for the power measurement system of a R9 290X, and that was just sort of, that was a disaster. I mean, the card worked, but it was just so bad. Just making sure, there we go. That's hooked up. Right, and I still need to pull 12 volts to that end. Oh man, this is ugly. Oh well, we'll do the other lower voltage connection now. Though I do need to pull some more SMDs. And these are just, well, let's see. Let's see. Can I get you out? Okay, I can get that one out. Come on. That's another one. Come on. Oh no, I don't want to. Oh man, I lifted the entire capacitor. Oops. Come on. Don't make me hammer you out again. There. Perfect. Got that one out as well. There. So now we can finally do the low voltage end, which I'll just pull right across the IC because that's the shortest path. And then I can just pull the 12 volts around it. Go. I want to be like this. There we go. Now this is a lot more painful than all the other power mods, but hopefully it pays off. Alright, and now I need to pull 12 volts. That's going to be so much fun. I should have tested on the 960 if you can just short out some of the other ones first. Because theoretically, right, if the card, well, I'm not sure if it actually checks how many, if there's like a limit for how many of the inputs have to be working before the safety triggers. And if it only has to have one of the channels like measuring a power consumption, then theoretically I could just, you know, could have just shorted out this cap, shorted out that cap, and called it a day. But, yeah, well, too late now. I basically have to attach one more wire at this point, so it'd be kind of pointless to back out. God, this looks awful. This looks so bad. Like, looks like a, like, go, and I need to do like a U-turn around there. Great. Build another V. Great, I messed up all of my single core wire, so it's going to be fun untangling that after the stream. But what I won't do for megahertz. Okay, let's see. Not vented enough. Definitely not enough. It's so hard to judge like distances because it's like, well, there it does. It looks like a mile on the PCB, and then you realize, well, by human scale, that's actually tiny. At least for me, that seems to be a problem. Is like I try to get a piece of wire to match the distances I need to do, and it's like always too long. Okay, so yeah, somehow just never. There we go. That's about right. There. Finally. Prepare to burn my fingers. Go. Luckily, and that's way too much solder on the end of that. Perfect. This might actually be a neat looking connection. Well, on one end, not the other. That's assuming I can actually, I need to re-length, like slightly tweak the bend. Thing is, I'm really worried about like putting too much strain on the capacitor there if I pull on this wire. Like ripping it out or something, that would really suck. And I have done that on a few cards, and then you're screwed. Well, I'm screwed because I don't have the skills to fix that kind of damage. There, I'll call that good. Yeah, okay, that's connected. There we go. So that disaster is how you blow out the NVIDIA power limit. So there we go. That horrific mess will hopefully not burn my house down and not break the card. And it should also mean that the card now reads a really low power limit, and then if it, well, it should, I think it'll get stuck at like 30% power limit. Which is good enough for my purposes. Because basically, as long as you're below like a certain minimum power draw, it'll work. So this should be good. And my house is gonna burn in 3, 2, 1. Okay, so it's not triggered safety mode, so that's first good sign. We have display output. Haha, it works. Deal with it, no video. Your power limits cannot restrain me. Unlimited power. And we have a problem. Big problem. That is really, really bad. Damn it. There is no power reading. What the hell? Did I screw some? I don't do this kind of thing in NVIDIA, okay? I don't do not working. So I will get my voltage readings on that. And this fan will have to take a bit of a vacation over there. And very carefully not kill the card. Ah. I have made a... Ah! Yeah, okay, no, I see it. I made a short circuit. My soldering just sucks. No worries. I screwed up the soldering. NVIDIA will be defeated today. Give me a few seconds. Okay, I'm not even gonna take you... I'm not even gonna have you watch this part because honestly, this is just there's a little bit of solder spillover from one giant blob that I made onto another giant blob that I made, and oh, that actually might suck really badly to try fix. I should have checked the resistance across all of those connections I made, but no worries, no worries, no worries. There's a reason why there's a resistor mode on resistance measuring mode on multimeters, and it's because you're supposed to use it to check your work. And I obviously failed to do that most basic thing, because evidently I have a short circuit across this pile of garbage. Eh? Okay, wait. Why are there... Yeah, there's a short circuit. So it's exactly what I thought it would be. So yeah, if you get a short circuit, it doesn't work. No Vcore. Oh man, this is gonna be... Actually, this is gonna be a pain to repair. I don't really want to remove all of my awful soldering. I think we're good. I think we're good. Give me a second, I need to check. Trash multimeter, what's the resistance? Tell me. The resistance is 96 ohms. That's a lot more than 0, isn't it? We have a working... It's work. This time it works. I will not be defeated. Spent far too much time, far too much effort on circumventing your idiotic little software limitations. I am not about to have my work defeated by my terrible soldering skills. For the person who just joined, the NVIDIA power limit is about to meet its maker, or I'm about to get really, really annoyed. Oh, look! The NVIDIA power limit has met its maker! Lose it! Ha! So as you can clearly see, we are completely idle! We're at 139 megahertz and we're reading 56% of TDP. I can't believe it! I can make it read whatever kind of power consumption I want! Whenever I want! Whenever I need it! Okay, so let's throw a little bit of load at the card just to make sure that it can still go into full 3D clocks, eh? Oh, look at that! We're at 1860 megahertz core clock! I do believe I beat your sorry power limit right into the ground. Isn't that right? Okay. It does seem like having it stuck at 55% may not be the best idea, so I'm gonna go pile on another resistor to drop the power limit, to drop the reading into something a little bit more, you know, celebration worthy. But I want to check one other thing, which is something I was, because on the overclock.net thread for modding NVIDIA cards, they were complaining about something called the NVIDIA normalized power limit, which I'm not sure, this might have overridden it. That's what I'm hoping. If that hasn't... Normalized, yeah. What you gonna do now? No more damned throttling. That, ladies and gentlemen, is how you remove a power limit. I'm gonna go pull the damn thing down and we're gonna see how it looks fully loaded. Because here's the thing, I was really worried there was a whole separate power sensing circuit that would note that is the normalized thing, but there isn't. So NVIDIA's power limit can go suck it. Now where is my 18? I'm back. I kind of expected that to happen today, because I have used the same pack of batteries for like 3 streams now, so yeah, I'm back. What is the NVIDIA power limit? Oh look, 9.5% TDP. That's a lot better in my opinion, eh? That looks a lot more professional than having it at like 56%. Just, eh. I don't think, actually, I think you can set the power, how low can we set the power limit in Afterburner? Just to really drive the point home. Oh, wait, temp limit, power limit, oh, it goes down to 49%. I mean, I couldn't care less where that freaking slider bottoms out. We're gonna run it 49% power limit. And we're gonna run 3D Mark on this. Guarantee it'll be fine. And I was gonna check that this Yeah, clock's up as usual. Let's get this thing dialed in. So the thing is, I know for a fact that this card, once you blow out the power limit, doesn't want... Like, it won't overclock properly, which causes issues. So we're just going to set 100 megahertz to start with, and we're going to run that because it'll boost higher because there's no power limit any longer. And when it does that, it tends to crash, which is one of my main complaints for the boost algorithm. We're also going to check hardware info just to make absolutely 100% sure that this mod is working as good as I expect it to be working. Which I think it probably is. Indeed, it is. 9.5% for both of those stupid things. Let's run 3D Mark. Show me what you got. I'm on a Ryzen 7 1700 4 gigahertz. Well, you mean more like... Wait. Let's see. Somebody asked for setup change, but I don't think it changes that much. Because I'm still like, wait. I guess if I, properties... Oh no, I can't be bothered changing this in the middle of a live stream. This motherboard doesn't have an AGSA 1006 yet. Will I LN2 this card? Of course I will. How else do you think I'm going to win Stage 5 with a Ryzen 700, 1700 when there's 6950Xs going there? Yeah, I'd really love to have the 1006 AGSA for this board. Because this board doesn't have BCLK, so it's stuck at 3200. Yeah, I have a 6950X, I just don't have a Asus motherboard for it. So I can't use it in the ROG OC Showdown competition, which is the entire reason why I have the GTX 1070 here. I'm not gonna run Furmark. I don't trust the VRM enough. I'd prefer to have a working card. Let's put it that way. This mod working has me more hyped than like the half a liter of energy drink I drank earlier today. Like I was sort of starting to fall asleep before the stream started. Wait, VRM on what? The motherboard or the card? Because the card there's a little heatsink under the main GPU heatsink. I go over that in the teardown. Oh, actually, speaking of, somebody just said speaking LN2 on VRM. There is actually a case of somebody doing that. Oh no. There. So glad I managed to find this. There. What just happened? I think the... Looks like it crashed. 280 Tri-X, yeah, sure. Send them right over. VRM's well, so the thing is, most VRM, capacitors hate being cold. They literally get worse the colder you run them. MOSFETs are really, really happy if they're cold. but they're only rated to function down to like minus 55 degrees. Below that, they might cold bug or something, and they won't actually turn on any longer. But yeah, you can totally hover a VRM at like minus 50. And I think the CPU just crashed. I don't think that was the GPU. Because this board is, like, it's not even proper 1.4 volts. It's just under 1.4 volts. It's a 4-phase VRM. To be fair, this 4-phase VRM doesn't get that hot running the 8-core. So it's like, if you want it for a day, like, I've considered taking this motherboard and using it to replace my X99, my daily X99 system, which is a 5930K, just because a Ryzen 8-core would be better for, like, I just want a Ryzen 8-core instead of a 5930K. I hate X99. So, you know, it's like, I'd like to say that my excuse is that I'm a live streamer, but quite frankly, it's like I don't game and stream at the same time, so it's not like it's going to make a huge difference. Yeah, big external capacitor banks. Thing is, depending on what kind of... So the thing about capacitor modding VRMs is depending on what kind of... Like, because basically you're adding on either... You're either putting smoothing capacitors for the ripple of the VRM itself, which you shouldn't really need to do, or you're adding decoupling capacitors. If you're adding decoupling capacitors, then you're trying to filter some you're basically trying to smooth out a lot of very high frequency noise caused by the GPU's functioning. For a lot of that stuff, the closer you can get it to the GPU core, the better. And actually, capacitance isn't the only thing you need to consider. You have to, like, ceramic capacitors work way better at lower for higher frequency voltage fluctuations, which is why you have a pile of them right behind the GPU core. But I plan to do a ton of testing on that in the future. So, yeah, I'd like to get a working time spy run in. And it does look like, yeah, the system completely crashed, so... I'm still going to run the power limit low, just to show off. It just makes me feel better. I'm going to not run the card full out again. Max those. And I do want hardware info. And GPU-Z. And let's run. Yeah, I've seen the beta BIOS for the Taichi with the 1006 AGSA. I know about it. What was the CPU limitation in the last crash? Not enough Vcore. It's really that simple. This board doesn't do enough Vcore. On the Taichi, I can run 4 gigahertz completely stable at like 1.41, and this goes to like 1.387, it's like, yeah, it's not really 1.4 volts. It's almost there, but it's not quite. And sometimes it crashes in the last test. The Taichi, I can actually run 1.42 volts and 4.05 gigahertz with occasional crashes. So, yeah, yeah. I think maybe piling on some extra capacitors onto the VRM of the motherboard might actually help, but I don't feel like tearing down the entire system to do that. So, on today's stream, because we have a lot more to do on the 1070. So, yeah. And, yeah, the Taichi, that's with LLC level 3. The 1.42 volts LLC level 3. I hate the summer. I'm hot, the GPU's hot, the CPU's hot, the VRM's hot, everything's hot. No, wait, Australia, it's winter there. Oh, that could... Right, it's winter there now. But isn't, like, the rest of the year, like, hell? Like, your summer is even worse than here? I think I'm just gonna move even further north. So, like, past the permafrost. I mean, it's relatively not, like, outside it's not hot. It's just, like, I have all my heating is turned off. I guess it's like the Fury X and that, and then this running, and the... I don't know, I must be burning a ton of electricity. Oh, I have a friend in Italy, he told me that it's like, I'm never going there. I don't care for that kind of weather. In the Czech Republic, I think the hottest it's ever been is like 37 degrees or something. So that's about as hot as, like, that's probably the hottest I've ever been. So, yeah. Alright, tomorrow is going to be hotter. I'm just going to go and, like, climb into one of the D-Wars. just, just sit in it. I'm so warm. There we go. We got a score now. See? It did work. Okay, score sucks. But that's because we're not overclocked. Let's check out those power readings, eh? Yeah. Oh, wait. What the hell? What the... Why did it go... There's more power... There has to be more power measuring circuitry. Like, way more power measuring circuitry on the card. Oh my god, no! But where is it? Where on earth could that be? There's no... Okay, so I actually have pictures of the PCB. I'm gonna go check those out. We can sort of do a PCB breakdown on the stream. So, oh man. That is really annoying. There's literally a second power circuit, so, like, there has to be, because they can't be... Unless they're calculating it off of core clock, which is ridiculous. Though, funnily enough, GPU-Z isn't showing a lot of throttling, but I really, really want to know where the hell the card gets the, like, it can't just pull the number out of thin air. It needs to measure it somehow. I'd hope. Where did my little SD card reader go? Oh, this is great. Oh, there it went. But I need to find that thing. Because that is really, really not good. And that thing needs to die. I'm going to literally kill the thing if I find it. Oh, man. I do not appreciate my GPU's misbehaving. Okay. Oh, I don't have a picture of the back? Am I an idiot? Oh, no, I do. Okay. There. So, that's the card. Well, this is really not good. That's the voltage controller. That's our 6-phase VRM. There's memory power. That's a filter. That's a filter. There's one of our shunts. I mean, the other two are over here. Like, technically this thing can read power through the VRM, but it doesn't, like, it can't communicate with the GPU core because this thing runs on the PWM vid interface from NVIDIA, which is completely brain dead. You can't pass, like, you can't, they can't communicate back and forth. They can only communicate in one direction. So it can't be that. And it does look like the power reading is relatively accurate. Like, it's very similar to what it should be. One of these is the 1-volt PLL, and one of them is going to be 5 volts power for the VRM section. This is probably 5 volts power. And this is probably the PLL because we have a... Is that normal to have the oscillator that far away? Possible. That is obnoxious. How are they reading the power? Like, what's the reading called? It's normalized. Alright. Well, core clock throughout 3D Mark was pretty much rock steady. So let's try 120 megahertz core clock. But that looks really... That's a BIOS chip over there. But what on... How the... I mean, if it's on the back, then I have pictures of the back of the card as well. Where are they? There we go. Bam. So... The only really big IC is that. And this is not a good picture of the back of the card. It's not top down, it's sort of offset, but... Because there's nothing else that's intelligent, like... One thing I find really, like, these guys. I find these guys really, really suspicious. Right? Because there's two of them here. And... No, there's... Nah. Nope, there's not one. Looks like... Nope. But... I don't see anything left on the card. How on earth? I mean, the card is at 49% power limit according to Afterburner. And yet it's not throttling to hell? So... I am confused. Like, really confused. Yeah, turn power limit all the way up and see if the score goes up. It sounds like a good suggestion. I'll try that. We'll skip physics. I don't want to risk the CPU crashing on me. So, that's 6K 400. Where is it pulling that power reading? Let's see. If it goes past 6400, like a lot past 6400, I have a problem. Alright. Clock more or less holding steady, though. Oh. This is with a Ryzen 7 1700. For the guy asking about the CPU. Yeah, non-X. I mean, at this point, I'm thinking they're just arbitrarily calculating the number. Or there's literally something built into the GPU die itself measuring the power consumption. Because AMD has that on some of their cards. So I'd be surprised if NVIDIA couldn't do the same. I mean, yeah, I mean, power limit set to 49% in Afterburner, and it's hitting 95% normalized, so... I don't know. I really don't know what the normalized power limit is. I mean, I didn't know about it until, like, earlier today, so I didn't even think it'd be an issue, but... It is concerning. What happens if I hit 100% normalized? Does it throttle? Because that's the thing I'm worried about, right? I mean, if it says that I'm pulling a 200% normalized power limit and it's not throttling, I don't care. It's just like, what happens if I hit 100? Because so far hasn't hit 100 yet. So, I guess open Furmark and hope for the best. Which I don't even have Furmark. I'm going to have to download that. Furmark. Now, it's scoring the same. So the power limit doesn't do anything any longer. This hasn't gone up. I'm afraid it'll crash at 150 offset. Because this is pretty borderline for this card off the top of my head, so... I think it completely maxes out at like 160, at which point you can barely get a run in. But... I mean, as long as it doesn't throttle, I don't really care if the normalized power draw is really high. But that is concerning. Because pretty much this confirms that the normalized power draw is not the INA 3221. That's not what does it. But there's not really anything else on the card that I could see doing that. Short of it being built into the GPU core. I wonder if they might not literally just be calculating it off of the clock, which would be stupid, but... But they could do that. Oh, it crashed. Yeah, this scene, it just doesn't make it past this scene. %98.8%. That's the frequency curve. Okay. Let's set that to 130. Wait, how's my voltage? My load voltage is pegged at 108. Great. Okay, we're gonna do... can I just how can I just flatline this? That is... Wait, what? That is stupid as hell! Can I just tell it to flatline? I want a flat line. Can I not ask for that? Damn useless video. Okay. I am not impressed. I am really not impressed. 203. 203. God, this is awful. This is so... Why is this a thing? God, I hate freaking lookup tables. I'm just gonna pull it all, like, I'm just gonna set it to 2 gigahertz across the... Wait, if I want to check something. If I now... Oh, wait. No, I didn't reset my curve, so... Oh, no. Oh, no. No. Why is this a thing? Like, why is this a thing? Who thought this is a good idea? This is worse than the ASRock BIOS. This is the most... Kill me. Kill me now. I never asked for this. I'm going to send a very strongly worded message to NVIDIA. They're never going to send me a card again. Well, actually, there will never be a chance of me getting a card. I think I'm happy with this curve. Right? Let's see what this does in 3D Mark. Run. Oh, also for the 2 gigahertz at 800 millivolts, I assure you we're gonna solve that later. Wait, I still need to hit apply? Wait a minute. Apply, but wait. Can I move these points? Oh, I can't move them. Oh, you know how fun it would have been if I could just move all the points to the freaking side? Wait, what? Why did you lower that? No, that's dumb. I don't want it lower than that. Whatever. We'll see. We'll see. We'll see what this does. Here's what I'm going to do next. I'm going to... So, NVIDIA GPUs use an ingenious communication standard for communicating what kind of core voltage they want, called PWM vid, where the GPU core sends a PWM signal to the UP9511, which the UP9511 then converts into core voltage. Now, the cool thing about this... Oh, well, I mean, yeah. I kind of expected that. The cool thing about this incredibly idiotic method of voltage control is that it's really, really easy to override. So we're going to do that, because I want to be able to take this stupid thing, make it a flat line, and then manually hard lock the voltage. So we're going to go do that. Right here. Right now. Because it's like, evidently the normalized power... If the normalized power limit turns out to be a problem later, we're going to fix it. Well, I'm probably not going to be able to fix it. But I can certainly wreck the voltage controller. And that will make me feel a lot better. So let me pull up my data sheets. And actually, well, let's explain this. Ambulance. Nope, this. So let me... Oh man, I don't know how to... New. That's too big. So here is our subject. The lovely UP9511. In all its glory. Boom. So, this thing is also, this UPI confidential doesn't mean anything, because here's a little cool little thing. Nope, don't save that. This is just how confidential the UPI datasheet is. P11, documents. This is how confidential that is. That's your datasheet for you. Either way, this horrific monstrosity right here is the voltage controller on the GTX 1070 Dual. And so, actually, I should probably get the datasheet open here as well. Wait, I should have a copy of it backed up somewhere on my computer. Datasheets, controllers. Hello, trash. Okay. No. So UPI 9511. That's the schematic which we're going to be scribbling on. But basically, we have ref in, vref. So reference input. Connect this pin to an external reference voltage through a resistor or connect to the output of the ref ADJ circuit. This is important. So we're going to get to that. There's one other data sheet I need. Which, where did that go? Okay. Oh, yeah, okay, found that. Download. Where did my... Oh, give me a second. Third monitor things. Did that break everything? No, it didn't. Good. So let me just save that and open it. This is the NVIDIA Open VREG specification. Why is it called open? I have no idea, but it is publicly accessible to everyone, which was a bad idea on NVIDIA's part and a good thing for me. We want PWM vid. Next. Oh, God. Okay, you know what? Open VREG. PWM vid. There. So PWM vid, dynamic voltage control analog method. PWM vid is a single-wire dynamic voltage control circuit. Driven by pulse width modulation method, this circuit reduces the device pin count and enables a wide dynamic voltage range. This is great, except we have I2C, and you could then also, like, talk to the voltage controller and, like, ask for power draw figures and all kinds of things, you know? Like, that's what normal companies like AMD do. But no, NVIDIA needed a single-pin PWM voltage control interface, which you can't communicate over this at all. It's dead. Basically, GPU sends PWM signal, voltage controller does whatever it says. But the vid PWM duty cycle determines the variable output voltage at ref in. So ref in, right, is, wait, I'm losing track of my data sheet. So that's the reference input. Variable output voltage. Basically, the ref in, whatever goes into reference in, is the voltage you get on the other side of the VRM. Great. So that's one thing. Vmin is 0% duty cycle voltage value. Vmax is the 100% duty cycle. So basically, if you wanted to manually override the PWM vid thing, you could theoretically hook up your own PWM square waveform generator running the right PWM signal, and then you can write whatever voltage you want to the voltage controller. But we don't really want to do that because that's way more complicated than the alternatives. So the way this basically works is, well, you have this little circuit here. But basically, PWM goes into the voltage controller, goes to the reference adjust pin, which is this guy right here. So you basically go like this. This is the PWM vid pin, so pin 39. That goes to ref ADJ. Ref ADJ then spits something out into this circuitry right here, and that tweaks the voltage on ref in. And depending on the voltage on ref in, the PWM cycle on the actual VRM is changed to get a different V out. So if we want to put manual voltage control, we just need to cut this. Disconnect that, bam. GPU is in manual voltage control. The problem with this is, I don't know what voltage it'll try to boot at, and VREF right here is 2 volts. So my assumption is it's going to try to boot straight 2 volts. So this is going to go really, really good on that basis. I'm really not sure what to expect, because VREF is straight 2 volts, and I know that because the data sheet for the UP9511 says so. Reference voltage, 2 volt LDO voltage output pin, connect at least 1 UF decoupling capacitor between this pin and ground. Yeah. So that's our decoupling capacitor. This resistor and that resistor then dictate the reference in voltage. This circuit exists for, basically there is a sort of standby mode, and that circuit is used for enabling standby mode, essentially. So yeah, it's sort of visible here. Yeah. But there should be a typical... Oh, how convenient. We can actually reverse completely. Vmax is our resistance Vref divided by resistance Vref plus resistance Vref1 resistance ref ADJ. Great. So we can actually calculate Vmax, because I don't want the voltage to just shoot through the roof when we boot up, which is really, really like, I don't want the card trying to boot 2 volts. That's a great way to not have a card. So I don't think that'll actually happen just because of how it's wired, but we'll see. V-step is, I don't really care. V-min is Vref. So I need to figure out what those resistors on the 1070 dual are. And according to this circuit, we're basically going to be... Oops. According to this circuit diagram... Let me get a... Yeah, that's better. That should be ref ADJ. That should be Vref1. I wonder what this is. We'll have to refer to the NVIDIA datasheet for that, because they do have a better... Vref, no. Ref ADJ. Capacitor ref in. Oh, God. Okay, I'm sorry. I'm just going to put this on my second monitor so I can see both at the same time properly. FBRTN goes straight to ground, though. That's this one. Oh, no, it doesn't go straight to ground. I hate these complicated... These complex feedback circuits, I hate them. These are such a pain to work with, because typically, if you try to pull the FB pin to ground on these through a potentiometer, it doesn't work, which is just, you know, so pleasant. RVREF2 is a resistor going to ground. That's not at all in this diagram here. It's just like, ref ADJ has this resistor, that resistor, and then FBRTN, which FBRTN doesn't even go to ground properly either. So... I guess it's best to try look at how Asus have wired it on the GTX. How it's wired on the 1070. So let's go to this photo. Hopefully we can zoom in enough. So there's our lovely UP9511. Let's start. Yeah, we're not going to be able to trace out properly from this. You can just about make out some of the traces, but that's really not what this photo is for. What is with these unpopular... Like, this looks like there's... Oh, that's the programmable pin array. Okay, so that's cool. So these guys right here are, you can set LLC, you can set switching frequency, you can set a bunch of things just by tweaking the resistances across those, which is probably what these are, which actually, those are pin, well, one of them is pin 12, but one of them is 35, 24, 23, 33, 34, 26. Multi-layer PCB, so I can't actually say that's what they are. Great. Lovely. Love you, Asus. Well, and UP9511. Seriously. You know what's funny? This only needs to exist because the voltage controller doesn't have an I2C interface. Because unlike an international rectifier voltage controller with I2C, you can tell it what switching frequency you want over the interface. But you can't do that when you're running PWM vid because it's a stupid little voltage control only interface, which is just great. But it does make some things more convenient. On the other hand, that's why you can't get software voltage control at all, because you have to access the voltage control through the NVIDIA driver, which is why NVIDIA dictates how much voltage you can get. So that's fun. Now I'm just gonna go and look at the pinout diagram. So that's fun. This is really dumb. This right here is pin 1. This here. And this right here is 40. That's reference ADJ. This guy right here. Actually, yeah. So pin 1, that's ref in. Ref in. There, that's ref in. Pin 40 is our ref ADJ. I do not give a damn about the capitalization here. Vid pin is this dump is what? The vid pin is this thing right here. That's vid. Vref is right here, so that's our 2-volt source. That's 2V. Huh. I'm starting to think that most of that circuit might be on the back of the card. Yeah. Oh man, I hate when I have to trace through a board. Well, it's stabby time with the multimeter because this is about as far as we're getting from here because I can't see how the traces are wired. So, stabby time. Let's go. To the camera and to the work zone, so to speak. And I'm just gonna have you like that for now because, quite frankly, can you see the multimeter? Is that legible? Of course it's not legible. There's a ton of glare on it. Let's see. That is not even like... Yeah, it's... I can read it fine. It's perfectly visible to me. It's just cameras don't like cheap LCDs. But I'd like you to be able to see it, so stay. That looks like it might work. I can't tell from how, because I'm sitting far away from the monitors. So I need a screwdriver. Where did that go? Oh, I know. No, wait. Where the... That is... Oh, there it went. Time to take apart the card. So first we need to remove the shroud, which I'm going to need something to store all the screws from this, otherwise I'm going to lose them. In this case, I actually care. I don't know what... These are from the GTR, probably. There, we're just going to throw them in there. Since the GTR no longer needs any screws. Let's pull this apart. I am really annoyed, though. It's like, this is way more difficult than it has to be, but... Like, the thing is, the voltage isn't... Like, it's not holding steady 1.093, and once I put it under liquid nitrogen, I do not trust the VRM to act like the card to stay steady at all, so I want to override the software voltage control completely. There we go. That's disconnected. That's the front of the card. We need to keep going under it. And to get the shroud, well, the fin stack out. And there we go. There's our PCB. So now I'm actually going to move you down so you can sort... Well, you'll probably not be able to see anything anyway, but it's worth trying, I would say. It's like I have a whole second light source here, which for me is way brighter, and somehow these shadows manage to be this dark. But anyway, there's our UP9511. I already... Oh, this is actually decent. I can sort of see... Oh, okay. Yeah, so under this lighting, I can actually see how it traces out. That's not bad. That's really not bad. Yeah, okay, this will be easier than I was hoping for. Well, to some extent, because I can sort of see where what goes. So it's time to figure out how this garbage is wired. As far as I can tell, this test point right here is for the ref ADJ. So we'll try do that. Try measure that. Huh, it is. Okay. So this is super convenient for me. So when making PCBs, for testing purposes at the factories, for QA, they basically put random spots of just nothing. There's just a dot. And you can use those. Well, there's a dot right there, which is ref ADJ, which is way easier to probe than trying to probe the pins directly. So thank you, Asus, for making my life that much easier. Also, you may have noticed all the shunts on the card are shiny because they're covered in liquid metal. So I was just testing out how well that works, because I've never done the liquid metal mod until I got this card. So that leads to this resistor, by the looks of things. Indeed it does. And that resistor has a resistance of 6.23. Cool. I need something to write it down. Ugh. So, because this thing is a nightmare. I want to copy off my little diagram. So we have, that's pin 40. 1, 2, and 39 is vid. And we don't really care about vid, but 40 is ref ADJ, so ref ADJ 1 is ref in and 2 is vref. Cool. Cool. So ref in. I can't wait to do like the memory voltage or something, because that'll be so much easier than this. Ref and yeah, vref. And the fancy circuit from NVIDIA for this stupid thing is there's a resistor from vref to ref in, and okay, I'll need to copy that down. Give me a second. Wait, does the capacitor matter at all? No, it doesn't. Good. That is really good. So, ref ADJ goes to... Oh, man. Okay, so... Oh, okay, that's interesting. So basically, I have a resistor. Goes like this. Ref in, then goes... Yeah, there's no resistor on ref in itself. Ref in ties together vref through... vref has a resistor. And then there's another resistor to ground. So the official NVIDIA specification for their crazy thing is that this is how they expect... no, okay, camera won't do that. Oh well. You can just look up the OpenVREG thing. But I can start noting down the various resistors and how they're wired from this. So there should only be 3 resistors I need to deal with. There's 1 ref ADJ and 2 VREF ins. So VREF in 1 is the first one. So that's 1. VR1. No, 1 VR, 2 VR. Well, actually I should put F at the end of it just to make it not variable resistor. Then pin 40 has ref A, RFA. Those are the 3 resistors I need to figure out. And I should know how this thing is wired. And actually from that I can then calculate how their PWM duty cycle works. Like what range of the PWM duty cycle this GTX 1070 uses. It shouldn't be the full range. It really shouldn't. Because that'd just be weird if it was. So that there is 6.23. Yeah, okay, so that's cool. And if I'm not mistaken, then the ref in pin should have that 6.23 kilo ohms resistance to the ref ADJ pin. Literally, just straight that. So let's see. Get the light on it so I can sort of see the traces. And trace that. And that goes to there. So let's test that. Are we on 0? Why am I not getting 0? I'll try the probe that didn't have to be filed down because I snapped one. Accidentally put a chair leg on it. Okay. So I found ref in. Kinda. I'm not holding the probes well enough. This is too small. I need like super fine probes or something and a microscope or something like that for this kind of thing. Let's see how... Wait, why is there a resistor on this? Oh. What the hell? Is that by any chance connected to this? What the... That makes 0 sense. I'm confused. What on earth are they doing? VRF is the next door neighbor, so let's measure that. Okay, I found VREF. VREF goes to here. VREF to ref in is 18K, and ref in to ref ADJ is... Wait, no, that's not ref ADJ. This is ref ADJ. Is 10K. Interesting. Now there should be a resistor from VREF to ground, so let's see. Okay. I mean, there's a third resistor by the looks of how this is wired, but... Like, there's more resistors than there should be, but... Wait. I'll just try something. 24K? What's this? 16K. So there's actually more resistance to that. Oh, man. Well, like this. It's 24K again. Okay. Huh. So it looks like... Wait, and VREF to ground is 24K. Ref in to ground. No, ref into VREF is, come on, 18.6. And ref into is 10.37. Okay. K. All of that is thousands of ohms. 24K. And need to check one last time. Wait. Oh, wait. Oh, that is definitely... Yeah, no, that's definitely ref in. So, that's interesting. So one thing I was thinking, it'd be cool if I had like a multi-channel, like, yeah, this is just something I wish I had. If I had an oscilloscope, at this point what I could do is I could put a wire on the ref in pin, hook up the scope to that, run the card, and then watch the voltage change on the ref in pin versus Vcore, and I'd know for sure. I think it's 1-to-1. So, yeah, but this is just great. As far as I can understand it, ref in should always pull the voltage up. Let me just do a few quick checks. Like, if you put ref in at 0, the voltage goes down. If that's true, then I can, to hell with it, and I can set it up. And then, in fact, one way I could wire it is I could wire VREF to ref in through a potentiometer, so I could tweak the resistances up and down, except at that point, would be there'd be some dodgy things I'd have to do about that, but theoretically that would work. So I have ref in. And ref in then has a resistance, and another resistance, and another resistance. Then we have VREF, and that just sits at 2 volts all the time. What the hell? Okay, no, I need to take a look at that diagram one more time. Oh, I drew it wrong. No. Yeah, I drew it wrong. I'm dumb. Yeah, that's why it didn't make sense. I drew it wrong. I'm an idiot. Yeah, of course. No, that makes perfect sense. So, VREF is on a voltage divider. It's always sitting on a voltage divider. And, well, VREF has a voltage divider made up of 2 resistors. And in between those 2 resistors, ref in and VREF, the ref ADJ are hooked up. So ref in is hooked up to that. And then there's ref ADJ, and ref ADJ is another resistor. So under normal conditions, this circuit, no voltage coming out of the ref ADJ pin, which isn't normal conditions, but with no ref ADJ pin running, this should okay, so that's 18.6. This should this VRM should sit at Let me just take my calculator because I don't trust myself to do this kind of thing in my head. Wait. If I unhook ref ADJ, I end up with 1.55 volts? What? I must be not measuring this properly. Let's see, I'll try measure the resistance from one pin to the other. This is always the best way to try do this. Like, technically, yeah, if you can somehow get probes fine enough that you can measure from one pin to the other on one of these stupid things, do it. But most of the time, that's going to go absolutely trash. That's what I thought. Oh, wait, what? $17.3, what the? I really wish they gave me more test points. Oh well. Let's try to get into that, and I'm gonna go for the box cutter here. I'm gonna try expose a little bit of the trace, so as close to the pin as I can, so that there we go. That should be just about enough. It's like the smallest scratch ever. But it should be enough for me to measure directly from pin to pin instead of trying to measure across resistors that I'm not entirely sure are the first ones to be, like, aren't in, well, that I'm not entirely sure are hooked up the way I want them to be. No, it really is 18.6 kilo ohms from, but that would give me a stock voltage of like 1.55. Wait. If I put in 2 volts, 18.6K, then 24K, I'm going to lose 4. That's 42.6. Oh, don't tell me I'm that stupid. I might be. Well, it does seem like if I cut the ref at adjust pin, it'll default to low voltage at this point. So let's just cut it. So it should be safe. The card should not instantaneously die. Unfortunately, I don't have any other GPUs that run on the on this PWM vid interface, so I don't have anything like to test run on, which, yeah, that's the downfall of my YouTube channel. Is like, even if I was bigger, is like nobody will give you samples so that you can hack them up. Also, I'm not going there with a soldering iron. That would be awful. That resistor, it would be nice to know what resistance that resistor has if I ever decide to try replace it, which obviously will never succeed, but hey, best be prepared. It's 6.2. Okay. Removed 6.2. Actually, no, it's not necessarily 6.23 kilo ohms. It's 6.23 kilo ohms with whatever is in parallel with it, which is just like, I've fallen into that trap once before on a different card where I thought, okay, come on. Can't really, I'm really tempted to just cut the trace instead, because that'd be easier. But that's a lot, like, it wouldn't be repairable at that point. I know what, let's, smaller iron tip, do it the right way, not try to force it out. Because unlike on the actual voltage controller here, I don't have the luxury of having as much space to work in. That's, that. Let's see, which tip should I go for? This one, or... How big is that? This is big enough. The bigger the tip, the easier it will be to transfer heat. Also, the less accurate your work will be, so... But I'm removing stuff, so I don't need to be super accurate. So I just need to not remove everything in the vicinity, too. I'm just going to go something for a little bit too big. If I was trying to repair this, this would be the wrong thing to use, but I'm not repairing things, I'm breaking them. Wait for it to heat up. Check the chat. How boring am I? And we're up to speed. Well, up to heat. And I keep messing up which one I'm supposed to remove. I'm supposed to remove you. Come out. Huh, there we go. Removed it. Ta-da! I'm a wizard. Okay, that was a lot easier to do than it should have been. Now I'm going to check all the resistances again. I don't expect to see infinite, but I expect to see more than before. Oh, whoa. I'm either on the solder mask or it's going infinite. No, it's not going infinite. I was on the solder mask. 13 mega ohms. Neat. And 4K on the other side. Well, that's cool. So at this point, this should dive the voltage. Like, literally dive it. Just going to check my other resistances. Yeah, okay. Other resistances remain unchanged. Static voltage, now it should run in static voltage mode. It won't run properly. So we need to attach a voltage read point. I am surprised that that hasn't fallen apart yet. At the same time, that probably has more lead on it than, well, more tin on it than any other part of the card. We do need a voltage read point. Otherwise, we're not going to go anywhere with this. So, yeah. So, life with NVIDIA GPUs. As I said earlier, you cannot measure the electrical resistance of an NVIDIA GPU because you end up in this situation, right? There's your multimeter. You measure across these big capacitors, and, okay, that's because there's crap on top of the tin, but... Okay, you know what? Let's measure across these guys here, because these guys are from the Vcore VRM. As you can clearly see, it's reading like 0.5 or something, which unfortunately on this multimeter is... Oh. Am I lucky? I could just be reading the resistance of something else. So yeah, it's like 0.2, and then I go to ground, 0.2, ground to ground, 0.2. Yeah, you just can't tell. So I'll, inadvisable, but I'll pull my Vcore read line from the output capacitors here, because these are marked on which side they're positive, and there's actually a point right here on the GPU that indicates that that's the GPU Vcore plane. So that's very easy for me to sort of work from to a usable read line. Now, yesterday, I was doing some work. Yesterday, when I was testing this power mod, I made this, so we'll just hook this up. I don't usually use yellow for Vcore. I was more thinking this would be like a nice color for PLL, but whatever. We'll use it since it's already available. I mean, there is a PLL voltage, and I will be modding that as well on this card, but actually, I'll show you how to figure out which voltage on this card is PLL right now. So, if we're lucky, so the thing is, Asus have very kindly, this is something that really surprised me, is they have marked points. Like here, we have PEX, right? That there is PEX. That is a point which we can use to find the VRM for PLL PEX voltage. It's 1 volt, but we need to find that. For LN2, it's an absolutely crucial voltage. It helps with black screen issues and all kinds of other weirdness. There we have 5 volts. It looks like my theory that was 5 volts is probably correct. Let's stand the card up and probe from the output of this VRM, right? We need to probe from this output right there, from the choke of that VRM, because the choke is the easiest thing to know for sure you're measuring the right side. The choke is always, oops, it's fine, it'll live. But yeah, the choke is always going to give you the right side of the voltage. You can't accidentally stab ground or something. So let's go for that. 1 probe on that end. Where's that voltage? I hate trying to probe through a GPU. This sucks. That is really odd. That is some very high resistance we got there. Let's see. Maybe it's just oxidization on the thing, but I don't think so. Well, the resistance dropped. Now it's in the K ohm range, so I'm going to say that's wrong. So that's the wrong one. Let's try the upper one. The other one on the card, which is this one up here. We're going to try... Where's my 5 volt? There we go. How I hate it when it's... Because you're putting pressure on 2 different points that aren't in parallel, so you get torque. Come on. Nah, I can't get a reading. Oh man, if this card was locked in a PCIe... Oh no, I threw that out. Oh wait, no, I have a better idea. I can still do it. So I had a... When I chopped up the Sabertooth 990FX board, I kept around the PCIe slot section of that board for a bit. And I used to use it for like standing GPUs up when I just needed to hold them up for me, but then I eventually decided to get rid of that, which looking back was a dumb idea. But hey, we have mini ITX motherboards, might as well use them. That's the Z270N Wi-Fi. I'm gonna put the card in the slot on that. Pop. That's gonna hold the card for me, and I can do my measurements! Yeah! So, yeah, and I'll put you back up on the overhead view. That's another ambulance. Let's go. So, I was trying to probe from this end to you. Now that's also reading in the kilo ohm range. What the hell? Is that the 5 volt? That can't be 5 volt. No, that isn't. Okay. Okay, that I know is wrong. Where on earth is the 5 volt VRM on this? Okay, so you? Oh, come on. Again in the kilo ohm range. Is that the P... Well, we could try if it's the PLL. No, that's kilo ohm range again. What the hell? Okay, is this the PLL? Because that would be nice to know. I mean, there's two candidates for PLL and 5 volts. One of them's got to be one of these. Oh, there we go. Found the PLL. Yeah, so... Man, these measurements are such a pain to take. Yeah, okay, there we go. That's PLL. Found it. So the lower... This little one down here, that's PLL. Now we still need to find the 5 volt VRM, which... Actually, to be fair, that could be this giant regulator right here, which would, you know, be a sort of obvious assumption. I'm just not sure what that chip is, so I don't actually know which end of it to measure from. And I am doing this because I'm waiting for the soldering iron to cool off. That's an... Well, I don't know what that is, so... I've never seen one of those before. But, we can try measure from it. To 5 volts. And this turned off because it's very smart. 5 volts. Looks like that might be it. Which would be nice enough if I could just get my damned measurement. Let's put it back in the motherboard. You go. Up. From there to there. What the hell? I mean, it really doesn't matter where the 5 volt VRM is because I'm not going to do anything to it, but at this point I'm just interested. I want to find it. Okay, so it's not that. What the hell? How many? There's not that many chokes on this card. If it has a choke, I should have been able to find it by now. Oh. There's no caps there. That can't be it. The choke here has to be this one, because that one hasn't read anything so far, unless it's 1.8. Which it is. Okay, that's 1.8. So I still don't know where the 5 volts is. At this point, I don't even really care, because this is just a waste of time. The soldering iron's probably cooled off enough that I can use it at this point. Well, switch the tips and do my bigger soldering stuff. Then we can try boot the card, see what voltage it defaults to, and then we can try mod the voltage again. So, let's flip it over. Switch the... Yeah, okay, this is warm, but workable. Oops. Switch to the big one. There we go. And we can go attach this. Which actually I could also attach it here, which is even like closer to the GPU core. Might do that. Just intentionally lay it out like that. Yeah, that looks like a good idea. 240, 250, 260, 270, 290, 300, 15, 25, 36, 34. Yeah, okay, it's ready. Hitting 400 now. Come on. Okay. Yeah. I think I can solder to that. This card does not have a lot of mass to it. Like a lot of other cards, I tried to do this and I'd not be getting anywhere, but this one is not heavy. Makes sense, it's a budget card, but, well, budget PCB by 1070 standards. Ow, burnt myself. There. Our voltage read points now. So now I'll just mount the heatsink back onto the card. I'm not going to build the entire card again. I left the screws lying around even though I went and like allocated a little thing to hold them all for me, but whatever. I'm just going to mount only the heatsink because I just want to boot up the card, see what voltage it boots to, and then it's pulling the heatsink back off again and modding time. So I need more thermal paste. For testing like this, I just use Arctic MX4 because it's cheap. So I just need and it spreads easy. So I'm just gonna blob more thermal paste on what I've already got. There we go. Nice. Sort of. Yeah, that's way too much. There. That looks acceptable to me. Throw the card on that. Also, yeah, the thing I just attached is limited by a, I do believe, a 4.7 k ohm resistor. So I'll just throw the cooler on because basically if we're booting up the card right, this thing has 0 fan mode. So I can just boot it with just the heatsink and no fans. Can't run it like this, it would overheat. What on earth is it on? I thought the fin stack was flat. Oh, there's a screw. Where's this from? Mystery for another day. I can point a 120mm fan at this heatsink and it'll probably be happy. Like, even for load testing, so might be worth testing that. Go. We got the card. All ready to go. Throw it in the system and check out what it throws up on the VRM. I really hope this doesn't boot up to 1.55 volts. that would be a bad day. Because I might not have a card at that point. Well, actually, no. I think 1.55 volts for like just the second as it boots up would probably be okay. More than that would be a problem for air cooling. If I had it on liquid nitrogen, then it'd be fine, but it's not on liquid nitrogen. Yeah, that'll hold. Where did my multimeter go? That's what that looks like set up. I have no idea where the multimeter went. So try lighting it. It's not that dark in here. Actually, wait. There, that's probably better. Yeah, okay, multimeter. Where did I put it? It's not on the chair. Oh, there it went. So I'm just going to stab the bench table for this. The ground end. Voltage with that end. Prepare for fire and sparks. it might try to run out of voltage at which it can't even boot. Which, honestly, I'd prefer. 0.8. So my second calculation was correct. I completely forgot how to do... We actually have video. This will be incredible. See? We got Windows. No more voltage control for the evil NVIDIA overlord. The card is now hard locked at... card is hard locked at 0.83 volts. Normal idle voltage for a GTX 1070 is 0.65 according to GPU-Z. I've never checked. But yeah, card is functional. So off with the heatsink and on with the volt mod. NVIDIA never... So, you know, slowly, steadily taking back control of my GTX 1070. So, nope. Well, power limit seems to be gone. I'm not sure what'll happen once I shove what Vcore... Like, once I get manual Vcore control, because... Basically, the best way to test how bad the power limit is I shove 1.2 volts through the card, and it either does or doesn't throttle. If it doesn't, great. If it does, problems. So, now I'm not sure how I want to do my volt mod. Oh, that is so blown out. There's a reason why I had it on lower exposure. Actually, we're going to be at the setup for a little bit, so... Well, actually, it doesn't matter where I point the cam, because we're going to be in, here. There. So, pulling that resistor locked us at 0.83 volts. We can no longer access the voltage controller through... So, the resistor I pulled was this guy. This guy's got to go. Remove that guy, static voltage control. Problem is, now we need to get manual voltage control over the card. Now, my theory on how to do this is, this is ref in. This is vref. I assume that if, and these are basically, there's a, the way this looks is, let me hide that, is this, get me a new layer. This pin and that pin are wired like this. There's a resistor. There's another resistor. There's ground. Right? And from here, it goes like that. And right now, this here is 18.6K. And this right here is 24K. And if you aren't an idiot and do the calculation properly, that works out to, so you basically, so the way you calculate the voltage right there, which I made a mistake earlier today, which I'm so sorry about, is like, it's just, I can't believe I screwed it up that badly. Because this is like electronics fundamentals and I royally messed that up, but you take 18.6, and I want my drawing tablet. I cannot survive any longer trying to use the mouse. So you take 18.6, you add it to 24. You end up with 42 points, and then you do 18.6 over that, and that gives you the, wait a minute. Wait a minute. Where's the paper? It is like that. That is very odd. Okay, but basically that 18.6, and then you do times 2. Which, this lovely calculation right here works out to 0.87 volts, which, and we do times 2 because this is a 2-volt voltage source. That there is a 2 volts voltage source. And so we get 0.87. So, the thing is, you get 0.87 across here, not across there. So I don't know. I don't get it. But in theory, if I put a potentiometer in parallel with this, so basically I go and... How should I draw this? That's so small. Okay, you know what? Let's blow this up. There should be some empty space. There we go. We got some empty space. So basically, we have 2 pins, and we have VREF. Yeah, high school physics issues. I'm fully aware of that, but freaking... If it works, it works. It's my level of caring, which is why I make so many mistakes all the time, and I'm forgetful as hell, so, yeah. Do not just copy anything I do. Double check everything I ever do, because it's probably broken in some way, shape, or form. VREF, ref in. So this is 2 volts right here. Then there's a resistor and another resistor, and that goes to ground. Ref in hooks up right here. And normally you'd also have another resistor right here, and that goes to ref ADJ, right? So I'll just call that ref A. You remove that, you get static voltage control. Now, my idea is that we have this, and so that's the weird thing, right? Because this is 18.6 K. That's 24.24 K. So the voltage drop across this resistor should be like 1.127 volts. And the voltage drop across the first one should be 0.876. So how does this translate into 0.83? I mean, evidently it seems to be tied to this voltage drop up here. I guess the ref in isn't directly... Right, and if I pump the voltage... Yeah, so I need to raise the... Wait, what the hell? I'm assuming if I lowered this resistance, the voltage would go up. I guess the correlation of output voltage and input voltage is not 1-to-1. Well, that would explain it. Then this could easily be that. I mean, if it was through some kind of ratio, that makes my life a lot harder, doesn't it? Now, it would be really cool if I could just put a potentiometer that goes... So we have this part, but I'd really like to be able to just put a potentiometer like this, right, and have it go like that. And then all I have to do is set up the potentiometer to start with that 18.6 to 18.6 and 24K difference across it, which I only have 1K ohm potentiometers. So that'd be like 1.8. Also, there's the parallel resistance thing, but not fun. really not fun. Okay, so... Well, either way, I need to pull wires from this. And I could just use static resistors to push the voltages up and down for a bit until I figure out the relationship. And then I don't have to worry about having the potentiometer turned too far one direction or another direction. Yeah. Yeah, I could. Because basically, if I use just straight resistors, right, I can just go and put like because the normal resistance is like, normally the resistance from Vref to ref in is going to be, you're going to have 18.6 K, and ref in is going to be, well, yeah, that's your normal resistance from ref in to Vref. So if I want to tweak that down a little bit, I can very, very easily and relatively safely. And my ref in to ground, I can also tweak separately. Right? Because that's essentially what I'm looking at. So I can lower 18.6K easily enough. If the voltage goes up when I lower this resistance, then it works in... Well, yeah, I guess, yeah, then it would basically mean more voltage on ref in is more voltage on output through the weird ratio thing. And if lowering this resistance lowers voltage, then it means it's actually somehow figured out, like it somehow measures the voltage drop across the actual resistor, and that 0.87 volts to 0.83 volts conversion was just voltage droop or something. Well, that seems like the best way to do it. So, and to start with, I think I'll try to do by 10%, I think, so I'll need like 186 kilo ohm resistor. So I'll go for a 200, just to be safe. From 200 to, yeah, and we need 3 wires anyway, so that's going to be easy enough to build. And I think I do need to be, yeah, I need to be on the fine tip again, so, well, finer tip, because otherwise there's no way I'm soldering that stuff. That is way too fine. But this is not like a feedback pin mod, which is why I'm having so much trouble with this. Because normally I don't have to deal with all these stupid reference voltage and non-reference. How low should I put you? Put you as low as it goes. And ta-da! And let me just adjust the autofocus. And there, make it a bit darker. Ta-da! Okay. Let's work on this. So we need to pull the heatsink off again. We're going to be doing that a lot. And then we need to just hook up 3 wires, and then we can stick resistors in them to test how that affects Vcore. I think lowering... No, that doesn't make... No, maybe lowering ref in does actually... That's... Can't really wrap my... The resistor between ref in and Vref is like... I'm not sure. I'm really not sure. I have no idea what to expect at this point, because I've never dealt with this circuit. And it's like, well, the voltage on that pin dictates the output voltage. I just don't know in which, if they're 1-to-1, or if it's just a ratio, or if they're like reversed or something. Like less voltage gives you more output voltage, or more... Oh well. I guess if I read the NVIDIA datasheet long enough, I'd figure it out, but like, why would I do that? Is like, I can just tweak it up and down by 10%, and the voltage will go up by 10 or down by 10, and it's like, One of them will not break. It won't break the card if I do that. So I want these. Oh man. Oh man, those are tiny. Those SMDs. So I'm going to be soldering onto these guys. I love my life. It's like if everything was just way bigger, or I had way better soldering skills. One of the two. Either of the two would be great. That's going to be tough. That is going to be really tough. Basically, need to boop, boop, boop. Okay. All right, I need a... Oh, and I need a ground wire. Oh, well, ground's easy to solder. That's good. At least I don't have to do 3 of these panes. I just need to do 1. Okay, so white wire for the control line. And since I've already used white for my Vcore measurement, I'm going to use yellow, yellow for Vcore. I'm going to use yellow again for this so that I don't accidentally, if I hook it up to a potentiometer, I know which one it is. Just looking at the wire color instead of having to have labels or something. The only way that could possibly go wrong is if I'm working on the card, like I'm overclocking the card and forget that yellow is Vcore and then go like, oh, why is our memory voltage so low? Let's give it 1.8. Card's dead. Luckily, I haven't like totally standardized, like I don't have a, I don't think I have a learned standard for the voltages yet, so I shouldn't really run the risk of doing that by accident. How long do I want this? I want this to reach pretty far. There. We'll go for that. Little tip. There we go. Oh, that's a really good one. It's still bigger than the stupid little SMD thing. Oh, I hate that. It's like my freaking strip is bigger than the damn the little SMD resistor. Oh, and I really, really hope I don't accidentally lift that thing. That's gonna just... That's like good reason to commit suicide right there. Lift the entire freaking... Lift the resistor or lift the entire trace. Either of those would suck very, very badly because at that point it's just like I have no... Well, I could probably like rebuild the entire like the resistor network externally, but I don't really want to be doing that. Ouch, I just burnt myself. Okay. I'm not going to be attaching this right now. Not yet anyway. Because, yeah, that is going to be a pain. At least the traces are big enough to see them. That's a good thing. On some cards, you can't eyeball the traces, which made this relatively easy to do. So that's... Yeah, so yellow will be VREF, and I want both of these the same length, so... Because they are from the same spot. Where should I pull my ground from? So many grounds. I don't know where to go. There we go. There. There we go. one end. That's the other end. Time to tin. There we go. Hate how if you like have the soldering iron on your wire too long when tinning, it starts melting the insulation. It ends up exposing more of it than you started with. Okay. So these two are now ready. I'll plasti dip them into place as soon as they're attached, because otherwise these guys are gonna, like, these wires on those SMDs, this is just like, this is the perfect way to rip everything out of the board. And I know that because I've done that on the GTX 570. That's the main reason the GTX 570 got an e-power, is because I ripped out the feedback circuit. Well, part of the feedback for the voltage controller, so the VRM would no longer work. So, yeah, that's why that got an e-power, because the VRM stopped working because I screwed up a volt mod. Now, theoretically, I could just e-power this too, but I'd rather not. You know, it's just, e-powers are a pain to do, and I prefer not having to do them if I don't have to. These tiny little SMDs are going to be the death of me. Can't even, okay, yeah, okay, yeah, okay, good. Oh, man. They're right next to each other. Kill me. I don't even know if VREF is the one that'll raise the... Oh, well. Man, this is gonna suck. This is gonna suck so bad. Okay, so... Stupid wire, I can't freaking hold it. There we go. That is such a dodgy connection. Oh man, that is like holding on by a strand of hair. That's how bad it is. Yeah, that just fell off again. That is very, very concerning. Why do I have to do these kinds of connections? The little VRM heatsink is actually managing to get in the way. That looks connected. Now, very gently move the wire. There. Problem is, I can't plasti dip this until I have both of them attached, and in that amount of time, I can easily knock out the first one. As in, like, disconnect it again, so... Oh, man. Oh, man. Why do I have to do this? Also, I went about the procedure wrong. I should have tinned both and then... Okay, wait, let's disconnect this one. Very carefully. And... Look. Okay. Ah, perfect. Okay, so they're both gonna grab. Wonder if I could do both of them at the same time. That might actually... No, that's a great way to short them out. Okay, that's a dumb idea. Would have been convenient, though. Just hold them together in the right positions and have it sorted like that. But which side of this? Yeah. I don't know why I blow on it. It's not going to do anything. It's freaking attached or it's not. Blowing on it. Oh well. Oh man, I'm still going to knock that other one out. I just touched it and... Oh man, I made it. I made it! I think. Yeah. They are both attached by, like, my faith in them and some of my hair. That's probably... Oh, man, that is so... Oh, God, I do not like that. That is... You're probably getting, like, a face full of hair, aren't you? Yeah, you are. For me. Sorry. Yeah, check that out. That is probably some of the finest soldering I've ever done. And I don't like those connections, but I can't, like, if I keep messing around with it, it's just, like, these are the ones that I really screw up really quickly, so get it once and never look at it again, because it might not be there the next time I try to look at it. So, Plasti Dip, and then we'll wait for it to dry for a bit, which while I wait for it to dry, I think I'll answer some questions. And, yeah. Oh man, it managed to disassociate again. Having Plasti Dip when it's standing still just has a tendency to separate out into the pigment and sort of clear gel stuff. Up. Why is this one moving? No, it's still attached. It is still attached. I was really worried that it, because it sort of flopped down, and I was really worried it disconnected. Because I've had that happen where it's like I go to apply the Plasti Dip and the wire disconnects. That's when I want... There. Now blowing on this stuff does make sense. It makes it dry faster. Solder doesn't dry though, so... Where did the paper towels go? Where did I put those? Oh, there. So now, Vivate. I'll check that it's hooked up through the pins after the Plasti Dip solidifies. And then we'll attach the ground line, and hooray, I can start messing around with the resistance and seeing how the voltage goes up and down. And then, you know what, I should have just bought like a truckload of different potentiometers, like 100K or something, when I was last shopping at DigiKey. Luckily, thanks to my work on testing the different capacitors, I've decided that I'm going to be testing even more capacitors, because I've made a discovery which is not to my liking. So obviously more testing until I find something, find an alternative solution is necessary. And so I will be buying more stuff from DigiKey probably very soon, so that actually I should have a good supply of potentiometers not too far in the future. Oh yeah, if there's a short circuit, the way I have those wires is they're both from the they're both on the pin side of their they're both from the pin side of the resistors that they're hooked up to. So yeah, that's that. Somebody asked how old am I? I'm 19, 20 this. Whoa, I'm gonna be 20. That completely escaped me. I'm gonna be 20 this summer. I need to stop acting like an idiot. Oh my god, that's a lot of follows. Okay, we need to clean out my Twitch. Da-da-da. Okay. Will I continue? Yes. I like the Taichi is currently the best Ryzen motherboard I have. I plan to work a lot with the Taichi. It's not going away. It's just a case of I don't have the time. Like, I haven't had the time until recently, and there's a beta BIOS, which I can't wait to try out, which makes overclocking memory so much better, and everything is just like, yay. You know, by the time I actually get around to putting Ryzen on liquid nitrogen, the BIOS might stop sucking. Yeah. Other than that, actually, speaking of like Ryzen and motherboards, I'm very strongly considering buying a Gigabyte K5 because Gigabyte announced another Ryzen, like Gigabyte just put out another overclocking competition. There's a Ryzen overclocking competition for Ryzen 5 and Ryzen 7 CPUs. There's cash prizes. They're literally giving away money. It's not parts, money. They're giving away straight cash, which is just, that's amazing. Competitions like this are so rare. In the overclocking world, it's like you usually have to go like to some world championship, which is like super exclusive, and cash prizes for a online competition is like I really want to join that. So I'm considering buying a Gigabyte Gaming K5 because that board has like something I didn't realize until recently. My current system does not have a second USB 3.0 internal header, which is now USB 3.1 type something, but still, it's USB 3.0. I don't have a second 3.0 header in my current system, so I bought a new, I bought a little hot swap bay for SSDs so I can, like, quickly back up images of Windows and stuff, and that also has, like, an SD card reader in it, and I can't use the SD card reader part of it because that's on USB 3.0, and I don't have a second header, so on the X99 board. So the K5 has that, and I'm like, well, it's cheap. It has BCLK overclocking. It looks good. I personally like the way the X370 K5 board looks. And the only thing is the VRM's a 4-phase, but hey, that gives me something to review. And yeah, so I'm considering buying that board and getting a 1700X to replace my personal rig, and I'll bin the 1700, like I'll test which of the two CPUs is better, and then I'll use whichever one is worse for my personal rig. So, yeah. Somebody was away for 10 minutes. I'm not sure what you missed if you were away for 10 minutes. So, yeah, I heard about the K5 BIOS being absolutely trash right now, but hey, I managed to make ASRock fix the Taichi BIOS by flipping out on video for a couple minutes. If I flip out a couple minutes, if I get the K5, flip out for a couple minutes, and they fix the BIOS, I think that's a win. So, yeah. What time is it? How long has this been going? 3 hours already, but yeah, it's like, damn, this stream's going to be a long one. I knew that going in. Ugh. This is like the AHOC Uber stream. Because I have to, I'm doing like a full card, which I never thought I'd do. But, I think it's progress for the live streams. Where did I learn how to mod cards? Google and Guts. That is now my official response for everything. How did you learn how to do X? Google and Guts, and I guess a bit of... I don't think I was lucky. You know, that's just like... I wouldn't say it's luck. Because if you want to be lucky with modding cards, that's how you kill an RX 480. Basically, ton of Google, and just Googling stuff, really, and then testing it out. And then not being afraid to test more out, because basically, it was like, okay, so this is how the usual Volt mod works, and then I was like, well, what if I step it up a notch, and step it up a notch, and, you know, you sort of... Because at the end of the day, rules of electronics don't randomly change just because your circuit, like, because of what your circuit is doing. If it's wired a certain way, it works the same, it does the same thing, so... I just sort of stepped it up, because normally everybody does Volt mods using just 2 wires where they have Vcore, they have the feedback to ground. I stepped that up to, I have a line for Vcore, feedback, and ground, and I use all 3 of them so that I can actually go, I can go down. That was one thing which was like, and the way I figured that out was I completely destroyed the feedback circuit on a 290X because I was trying to figure out how to feedback mod a Fury, and I knew right off the bat the 3567B is a pain to work with. So I'm like, okay, I need to practice on a card with a 3567B. So I did a 290X, I broke that. Like, the card runs, and actually I could e-power that card. If I get my hands on that card, it's getting an e-power. But I completely broke the feedback system on that card, and the problem was, I basically, something went wrong, and I went about, no, I know how that went. I only had 10k ohm potentiometers. I had 10k ohm potentiometers, and the resistance on the feedback line for a 3567B is like ohms. So you can't use a multi-kilo ohm potentiometer to control it. You're not going to do anything. So I'm like, so I'm sitting there like, right, but looking at the diagram for the 3567B, it's just a straight line to the Vcore. I know how a voltage divider works. What if I just disconnect, just completely disconnect the original feedback circuit and replace it with the potentiometer and two sense lines, one to ground, one to Vcore? And so I did that. And bam, the card, I can go all the way to 0.5 volts, and I can go all the way to, I think, like 2.5. Which I don't want to, but, you know, I can go to 0.5. So you basically, the problem with the card now is if you want to boot the card up, you need to manually configure the voltage because it won't start on its own. But that's how I figured out the three-wire voltage mod, which is what I use now. This ref ADJ thing was basically from the e-power mods, which I've done. It's like, I make an e-power, right? I cut off the communication between the voltage controller and the GPU, and the VRM still puts out a voltage. I should be able to make a VRM put out a voltage without having to cut off the entire GPU. So that's how I went, so that's how I got this idea to override the PWM vid thing. Admittedly, my idea was to just cut the PWM vid line. So with that, I just sort of was, I asked a contact of mine, is like, yo, what happens if I cut PWM vid? Would that give me static voltage control? And he's like, no, cut ref ADJ. So I'm like, okay, I'll cut ref ADJ. But I had no idea what ref ADJ does, so I did a bunch of research to figure out how on earth that works. Well, works. Still not. It just works enough so that I can, you know, not blow up the card by accident. I'm not real, like, yeah, I guess I could read into the details. It's just like, bored. Is that dry yet? That might be dry at this point. But yeah, basically sort of just, you know, did one thing, it worked that way. Could I apply it to this other thing? Maybe. Try, and sometimes it works, sometimes it doesn't. Which is why it's like, don't, but, you know, I don't really like having lots of high-end cards, because if you have high-end cards, you can't test stupid stuff on them. It's like you can only do safe things to high-end cards, because if you do stupid stuff to them, they break, and it's like, oh, well, that's 350 quid down the drain, or 500 quid down the drain, or 700 quid down the drain, or if you buy Titan XPs, 1,000. You know, it's just like, nope. So I tested my first volt mod on a 260X, and then I sort of started stepping it up from there. So yeah, I think that's dry at this point, so we'll go check out if my soldering is decent. I am not touching another GTX 10 anything card, if I can help it. I've had it. I've had it with NVIDIA. Well, actually, I'm not touching any NVIDIA cards anytime soon. I've had it with them. There we go. So, is that... Yeah, that's dry. That's dry. Okay. Well, mostly. But let's check the resistances at this point, because we do need to not blow up the card. That be... You know, VREF shorted to ref in would probably give me 2 volts. Maybe not. And if it did give me 2 volts, I'd be screwed. So we don't want that happening. So let's measure the resistance across these 2 wires. If they're 0, then we're good. What the hell? I think I have a problem. A big one. Those wires might not be connected at all. Like, in the most literal sense of not connected. Oh, you gotta be kidding me. That is very, very problematic. Yeah. That is a problem. Uh-oh. Uh-oh. I think my soldering skills were too bad and it disconnected. Because right now, ideally, these wires should be reading 18.6 kilo ohms between each other. Right now, they're not reading that. They're reading, well, they're not reading anything. They're not connected, according to my multimeter, which quite possibly means that one of them didn't hook up, which would suck. So let's probe. Oh, I am screwed. Oh no! What the hell? 0? Okay, so white line is good. White is good. Yellow now. Well, that's very concerning, isn't it? Yellow is reading garbage. That is not good. Oh wait, we're getting something. Come on. Now it's what? Jesus Christ, is this the multimeter? Are the probes not all the way in or something? Horrible pile of garbage. Give me a goddamn reading. Now it's good. Oh, are you kidding me? So what the hell was with this? Oh, now it's reading 8. Yeah. Okay, now it's reading 18 again. Man, this multimeter. This freaking multimeter is going to be the death of me. It's like, hook up, try to measure resistance across the 2 wires, infinite. Well, actually, it was my skin resistance because of how you have to hold it. And it's like, that's not possible. And it's like, okay, so these are hooked up at this point. We technically don't need the ground line to test these 2 first. Just gonna point that out. And abuse that fact. So, let's grab a screw terminal. Like so. And put both of these wires into it. Actually, before we do that, I'm going to bend these a little bit. Actually, I think I might plasti-dip these guys out further. Like, I need to secure them because otherwise they're just, like, yeah. These wires are way too thin to just leave them... Well, the components they're attaching to aren't strong enough, in my opinion, so... yeah, I'll probably have to tweak them a bit more, but... Like, put more... Well, no, not more plasti-dip, like... Zip tie them down or something, which will be a pain because these guys are tiny. There we go. And I just want to blob the endings of these so that I can get them into a screw terminal easily. So while we wait for that, I'm going to try to figure out a way to get these guys cable routed, like wire managed somehow. I like to pull them out to the end of the card sort of here. Don't put any strain on them and just like lock them in somehow. Huh. What do I have available for that? I guess I could take another piece of wire and just like tie them down with it. Oh no, that's the voltage measurement. That's the other voltage measurement line. There has to be some spare wire somewhere on this desk. There's such a mess on here that should be impossible. But there isn't one. Oh, there isn't. Okay. I mean, there's also the option of just trying to zip tie it down, but, I don't think that's going to work very well. Oh, and I just realized something. The shroud. The shroud has to go through, the shroud goes through several of the screw holes. So I can't just pick any random screw hole on the card and use it. I need to avoid whichever ones belong to the shroud. So, let's see. Shroud goes like this. One of these guys is unused, because we can see. So, if you see, we have 1, 2, shroud goes on like this, right? So we have 1 here, 2nd here, but there's 3 screw holes there, in that, on this bottom edge. This goes all the way to the edge, so I could use this screw hole right here. So I should be able to use this one, right there, to cable manage. Okay, so that's great. Now how do I cable manage? It'd be nice if I had some kind of like wrapper for the wires that I could then not like heat shrink, like soft, like something that I could like squeeze down on. Also, that's up to temperature. The problem with using really fine wires is like, how do you cable manage them? So you can't just zip tie them to anything. But on the other hand, making that connection with a thicker wire would be borderline impossible, so... I may have an idea. Then use a zip tie with this. Oh. This is some, this is a rubber O-ring for mounting, what is it? Mounting... hard drives. There. That's what I was looking for. Mounting hard drives in the DMOS Tech case that I have, so the test bench, so the other one I have. Let's see. Nope, that's not... Yeah, I was hoping I could get the zip tie into the groove on that, but that's not going to work. Damn it. There has to be something I can use for this. I mean, another alternative would be to like run those wires into a bigger wire and then run that out, but that just seems awfully inconvenient. Well, I'll deal with the endings on these and... Ouch. This one's too blobby. It's not blobby enough. That's perfect. Okay. Almost broke the card. Okay, maybe I could wrap the wires around something and then have that go... Oh, yeah, I could do that. Zip tie. Zip ties are the best thing ever. You can mount anything to everything with zip ties. I guarantee it. I'm gonna make a loop. I'm gonna run the wire... I'm gonna run these same wires through the loop a few times and then use that to basically give it the extra thickness necessary for them to hold in place. There, like, sort of like that. That looks awful. And I'm losing a lot of length to it, but whatever. As long as it works, I don't care. As long as these guys don't get ripped out of the freaking position they're in, I'm happy. And then somewhere along the line I need to add the black one to that. Well, great. I've seemingly... The distance is wrong. This one would... That screw hole's unused, but yeah, no way I'm routing it through there. That's not going to work. Okay. Well, it is what it is. It's... Yeah, that's too much. Just too much length. Well... Luckily, since these are just loops, I should be just able to force them back through. This heatsink doesn't come with anything to cool the memory, so I'm not concerned about that. Running over the memory chips is non-issue for this horrific idea of mine, but yeah, this is... Should take up weaving or something as a hobby. How much of this kind of garbage I have to deal with. And come on. Man, I really really hope this didn't break the wires, but... Repairing these would be easy at this point, I think. Okay, yeah, that is the right wire I'm pulling on, but... Let's see, grab the white one. That's the thing, right? I need to pull it through somehow. Why do I always make things difficult for myself? Screw it, I'll leave it like this. At this point, this is not too long, and yeah, that'll run into the shroud, but whatever. That's better than nothing. Than no management whatsoever. There. Now you can't... I mean, I can't overstress the cables. That's the main thing with this stupid idea of mine, but... Yeah. Yeah, the white one's just going to be a bit too long. Oh man, I just put a lot of... Don't go anywhere. I really hope I haven't screwed up that volt mod now. Well, I screwed up those wires yet. That'd be... If I screwed them up at this point, that'd be just... so much... Well, it wouldn't be that much work to undo it, but it'd be a lot of work wasted. Yeah. So... I don't think I've broken it yet. That's one caught. That's the second. And at this point, if I put a resistor through this, I should get a voltage change. Man, this is so not worth it, how much time I'm putting into this. Ugh. I don't think we'll get around to all the mods today. I might have to do another stream tomorrow, and after tomorrow, and Wednesday, and stream non-stop for the next few days to get this done, because this is... This is like a day-long project. There. Thermal paste on heatsink. Let's put these together again. And... oh man, that is so wrong. It's supposed to be like this. This isn't broken yet? No, that's still good. Perfect. I should have voltage control now. Oh, this broke. Genius me. I'll have to reattach that. That's not a huge deal. How did that break? Oh, my soldering skills do suck so badly. That's how. Literally. I was worried I just, like, twisted off the wire end, which I've had happen on one motherboard. But nope. I never got the resistor up to temperature, so it wasn't actually properly attached. Come on. Actually, don't do that above the GPU. That'd be a dumb idea. A big long list of dumb ideas, that would be one of the dumber ones. Oh, come on. Yay, do me that favor and stay there. Oh, now it doesn't look like garbage soldering. Great. It's nice and shiny. Looks good. Okay, so we can now go run this again. Ugh. How long am I taking to do one of these modifications? Probably a month. Da-da-da. Autofocus. To hell with it. Yeah, that took 40 minutes to do. Yeah, I work slow. But better slow and steady than trying to rush it and blowing up the card, so... Because as long as the card works, progress can be made. The moment the card stops working, I need to buy a new card, which won't be happening. Because I somehow need to afford Vega, and, you know, there is so much stuff coming out after Computex, which I want to buy, that I can't just burn all my money on buying GTX 1070s to kill. So, there we go. Well, burn the entire HOC budget on that. You know, I might just... Okay. So, let's hook this up. Ugh. Multimeter. Voltage mode. Wire this. This is not the best place to pull ground, but it's a ground. That'll work. We have voltage. This is not enabled yet. If the volt mod doesn't work, then we quit here. If it does work, then I'll continue, but it doesn't work. Okay, we are on the right input. It's a bit dark, wouldn't you say? There we go. And... well, the card still runs, obviously. That's like the bare minimum of what it should do. I was making a racket like hell. Okay, so 200k ohm resistor versus voltage control circuit. We shall commence. Oh, that's a 220. Why have I used up so many 220ks? Why haven't? Okay, we'll go with a 180 because I've used a lot of 220s. So there we go. I apply this, voltage will either go up or down, one of the two. That'll define how we continue from here. Up! That is interesting. That is very interesting. It goes up. There. That literally forces voltage up. That is very, very interesting. Oh. Right. That makes sense. That makes so much sense why that works that way. Of course it would. Because if there's less voltage drop, on the, so you have 2 volts, goes through the first resistor, then there's the second resistor to ground. So if there's less voltage drop on the first resistor, that means you have a higher voltage on the ref in pin. But there is a drop. There is a drop in voltage. Ref in of we can actually check because we do have it on the. Wait, how the hell is that 0.8? Ref in is 0.81. Vcore is 0.81. But that's an 18 point... $18.6K... What? Oh, maybe I should have measured ref in to ground. That might be the... Like, there'd be... Because if there was another... No! Oh, yeah. No. Yeah. No. Yeah. Okay. Totally on me. I'm dumb. Okay, that is totally on me. Right. Yeah, that makes... Right! I'm an idiot! How did I not see that? How am I so dense? Of course. Of course they're just... Oh, I'm stupid. I'm really stupid. Wait, no, what? Actually, no. Okay, I have no idea. I give up. It is too late at night. I have not enough sugar. I've certainly not eaten enough today, that's for sure, but... just streaming and thinking a lot is hard at the same time. So I don't get it. But I do have voltage control. Unfortunately, it's voltage control that... I don't feel safe trying to hook up a potentiometer to this. But I do feel safe shoving a resistor down it to get a higher voltage. Wait, I just want to check one more thing. That's ref in, right? Yeah. Damn. Okay, so... Yeah, okay, there's nothing for it. I need to turn this off. But we do have voltage control over the reference input side of the card, which is cool. That is really cool. That is... I don't think anybody's ever tried to control the voltage on a card this way, but... What's the resistance from ref in to ground? Ah! Yeah. Yeah, that explains so freaking much. I am a moron. Of course I am. Of course I am a moron. I did my measurements completely wrong. It's not the equation that's wrong. I'm a dunce. So, here's what I screwed up so badly. Let's scribble. So, my dumb... Okay. Oh, wait. Did that undo something? Okay, no. My incredibly intelligent... my massive brain decided that... Okay, wait. I need to redraw this circuit. And I'll do it with the freaking tablet. I want to give myself more space this time around, just to make sure that... Where's the pen? There it is. So, the thing I screwed up, right, we have our VREF of 2 volts. This spits out 2 volts. Then we have ref in. And they're like this. Then you have your resistor. Then you have another resistor. Then you have ground. So I've literally just redrawn that, but drawing it helps me keep track of what's in it. So, and then you have this, right? And my incredibly informed self decided that, you know, I'm going to measure the resistance from here to here, and that's 18.6K. Okay, that's correct. That's 18.6K ohm. But then I had the ingenious idea to measure the resistance from here to there, and that's 24K ohm. This resistor here is not 24K ohms. This one's 18.6, but this one really isn't 24. And interestingly enough, ref in through this resistor, like measuring from here to here, you see 13 let me just check it. Yeah, that gives you 13.93, which doesn't make a lot of sense, actually, thinking about that, right? But yeah, so ref in to ground is 13.9. That's 13.9K. You see the problem? This is not 24. It's 13.9. Now, how on earth VREF to ground reads 24K ohms? I don't know. And in fact, I think... Oh, right, there's actually... I sort of... Because in order for this to be 24K, like, from point 1 to point 2, 1 to 2... For that to be 24K ohms, that has to be 18.6 plus like 6K. So there has to be a resistor here as well, in which case VREF to ref in is not 18.6K here. In which case I basically don't know the resistance. I literally have no idea what this resistance or that resistance is. Actually is. Because there's a third resistor, and I never managed to fully trace out the circuit. Well, there might not even be just a third one. There might be a bunch more resistors. So that's not fun. But it does seem that in the default configuration of whatever the resistance values are, right here, you get 0.81 volts. On that point right there. That gets 0.81. So, that's that. And putting 180K ohm gives you 0.87. So about plus 6. I can work with that. Kinda. But yeah, it is unfortunate that I have no idea what the full how this is actually wired. Well, I mean, well, no, actually, I do know for a fact that no, because. That's the problem, right? Because in order for... Why can't I have... So, VREF to ref in, these two are 18.6K. That is 24. This is 13.9. And then there's some kind of connection between all of these that's question mark, question mark, question mark, and satisfies all of these. I'm not in the mood to do math right now. What? Because this is what it looks like. This is the measurements I actually have, not the stupid assumption I made. But you know what? It doesn't actually super matter, because we know that shoving a 180 gives me 0.87. Therefore, shoving half a 180... Actually, that's a dumb idea. I should not step it that quickly. Now I really wish I had a 2 kilo ohm potentiometer. If I had a 2 kilo ohm potentiometer, I could shove it in there and bam, solved. But I can't do that. So I would need the third ground line so that I can tweak ground resistance at the same time. No, actually, the cool thing is, the reason why I came up with my three-wire potentiometer control scheme is because technically, as long as your potentiometer is smaller than what you're messing with by a large enough amount, what you're messing with doesn't impact the potentiometer, the way the potentiometer affects the voltage significantly. Yes! I knew there was a reason why I was buying 1K ohms and not bigger ones. So, yeah. Too bad these are logarithmic, so we're going to have to put quite the limiter on these. But basically, right, like, regardless of what these resistances actually are, if I put a 1K ohm in parallel with ref in, to hell with it. Everything goes to hell. But we do know less resistance from Vref to ref in. Right. Right. We need that voltage relationship. If we don't have that, like, I need to wrap my head around it. If this resistance goes down, voltage goes up. Logically, because more of that 2 volts is fed into ref in. If this resistance goes up, so basically, because I want to know which way I have to turn the potentiometer to set the voltage really low to start with. Wait. 2V on one end. Ground. And that's our ref in. And the cool thing is, since this is a 1K ohm potentiometer, these things are just sort of random noise to it because they're too big to affect it. That's why I use 1K ohms and not something larger. Because as long as your potentiometer is small enough, you can use the 3-wire method. You can't use a 2-wire method. Because you can completely override the existing circuit with a lower resistance one. But you can't do, like, you can't override with a bigger one. So, yeah, bigger, higher resistance potentiometer. So, or the same size. 2 volts to ground. If I have 500 ohms on both sides, then I get 1 volt ref in. Yeah, this is simple, right? So if I lower this resistance and raise that one, voltage goes up. No. No, wait. My head is just toast right now. I'm really tempted to grab that, I do still have a can of energy drink on hand, but I've already had one, and that's like my daily limit because I do not, my caffeine tolerance is not high enough at all. And I'd like to keep it that way. Could the chat solve this question for me? Please, just, you do the math. I can no longer compute anything. My brain is like, pfft. So I'm just gonna wait for the chat. Which way do I need to turn the potentiometer to not blow up my card? Ugh. Which way do I turn the... And don't troll me, guys. Please don't troll me. Hidden resistor is 8K. Is it? Would that work? Guess it... Wait, but then this would be a 10. That would be a 6. 8. Oh. Wait. No. That wouldn't work. That wouldn't work. It can't be an 8. Because that would be 18, but that's 16, not 24. Unless you mean this one's 8. In which case this would be 16. This would be 2. No, because then this doesn't work out. There's a way, there's an equation to solve that, but I can't care. Which way does the... I mean, I could just wire up the potentiometer, set it to 500 in both directions. That would boot on 1 volt and then tweak it up and down, but that's a dumb idea. I literally no longer know how a voltage divider works. I've done too much. I'm an idiot. Like my... Wikipedia, God help me. Google help me. Can't believe it. This is like... They're 1-to-1, you get half your voltage loss on each. If one is 250 and the other is 750, I can work this out. I can definitely work this out. I want to finish this today, this volt mod. I can't, like, I won't be able to sleep without finishing this. That would be 0.2... Okay, you know what? Voltage dividers. Give me the equation. You know, it's funny. I was considering shoving a voltage divider functionality into my VRM calculator, but I never got around to actually finishing that functionality, so now I can't use it to cheat my... Cheat away. Okay, you know. Google save me. V in, V out equals V in, R2. Which one's R2? Oh, yeah, R2. Okay, so if I had 250 and 750, then it's 2 times 750 over 1,000. 1.5 volts. Yeah, I would have toasted the car. No. Yeah, we're packing up. We're packing up. I am too stupid to do this at this point. I have literally no idea what I'm doing, so we are ending here before I kill the card. It's been a good run, guys, but I can't do this for 4 hours, can I? No, I can't. Yeah. That was a thing. I am just... No, it's like numbers no longer make sense to me, so I give up. This is the best thing I can do for the GPU, because it's like, I think I solved that, and it's like somebody, I need a cheat sheet. I'm probably not going to go sleep. I'm going to go play PlanetSide or something, because Oh, wait, what time is it? I have no food in the house. I should probably go buy... That would be a great idea. Buy food, you incompetent imbecile. Stop thinking about capacitors and voltmods. Buy food. Might make you more functional when you're on a live stream, wouldn't it? But yeah, I hope you all enjoyed that, because I sure did. I'm like... right now. I think everybody's sort of realized that my usual thought processing capability is just over. Look, no. Nobody tell me about how to... Don't bother solving the resistors or anything. Just give up. Because I'm not even mentally, like, up enough to help you fix it. Also, my local shop is open up till 12, so I'm fine. I know I can go get food. It's just a case of I am... So... that's that. The power limit thing is still bugging me. Like, that's still bugging me. That's another battle for another day. How y'all think we could do a live stream? No, I can't do a live stream every day. That's just gonna end up with me being even deader tomorrow. So yeah, we didn't really get any amazing overclocks today, but I hope this stream showed you some of what goes into a modding process when you're mentally... Okay, wait. People want... Okay, wait. Let's see. This is just the easiest way. There. It's like wire. Literally, my hair is like wire. That's why I can do this with it. My mom used to complain that it would, like, dull scissors really quickly. My last exam is on the 5th of June, and it's on electronics. That sounds really bad after watching this stream. Okay. We are not streaming tomorrow, because I'm already over. We are not doing it tomorrow. No. No. No more. No more. Literally no more. This reminds me of that 6-hour live stream of the dual Crossfire RX 480s, where it's like, oh, it's because the 6950X has 10 cores and the drivers don't want to work. But this is worse because there's a GPU on the line here. So I think, what day is it? Today's Sunday. Monday, Tuesday. Tuesday we can stream, and I'll try put out a video tomorrow, some kind of... I'll do a PCB breakdown or something. Oh shit, almost spilled water all over my keyboard, I'm dumb. I can't even drink water at this point. I just said we're not doing tomorrow, get it through your thick skulls, damn it. Yeah, thank you for watching. Like, share, subscribe. I guess if you're watching on YouTube, you can leave a comment down in the comment section below. And if you would like to support what I do here at Actually Hardcore Overclocking, you can go use the PayPal, the Patreon, or check out the AHOC Junkyard, where there's loads of garbage that I haven't managed to kill available for you to buy in order to fund other new AHOC hardware acquisitions. Do I know what I can do a video on tomorrow? I can do a video on this. That should be nice and simple. I can probably figure out how a MOSFET works tomorrow. So yeah, that's it for this live stream. Thanks for watching, and see you on the next one, which will probably be Tuesday, but if there's no announcement, I'll make the title say that it's delayed. It's probably Tuesday at this rate. So yeah, that's that, and goodbye.